Yeah, I gotta update the link in the Discord now. That's a yeah, that sucks. Sucks big time. Big time. God fucking damn it. Okay. Okay, we're back. Yeah, sorry about that. So, yeah, we learned that we have to accept the 720p and move on with our lives. So I'm moving on with my life now. Anyway. Yeah, I tried to get it 1080p. I know that it would look a lot better. It's a bummer because when I look back on the stream or whatever, I see like a lot of, it's like, it just looks a lot more chunky and meh than like on my screen, right? Like on my screen it looks kind of like crisp and cool, but that is what it is. Like there's nothing I can really do about it until I get a new graphics card, and then when I get a new graphics card, then I have to get a new power supply and all of that, so it's a lot that I would have to get for this old computer. Yeah. What's up, Cheese? I hope your competition went well. Yeah. What was it for? Was it chess or something, or went okay. That's good. It was chess? Yeah. Well, I suck at chess, so is it like a local sort of is it like a club or like a chess club sort of thing? Or I kind of wanted to do a chess club when I was younger, but I never really committed to that. I was like mediocre, I guess. At some point it was alright. Anyway, so this load chunks function is gonna have to change. So we're running out of memory. We're literally out of VRAM with this, with the vertices. And so I went and consulted some internet people about what I can do about it, and the answer is not easy. The answer is very, very not easy. So there's a few things, right? So I have this as 28, right? So the idea is, right, we have at LOD 0 we have 1, just the one that we're standing on. At LOD 1 we have all of the surrounding chunks in a cube, which is 27. And then at LOD 2 we have, I guess view frustum, right, to see into the distance, right? So that was my idea, right? And so this might actually, like, LOD, oh my god, are you fucking, dude, I hate, I hate Helix sometimes. It fucking annoys me how there are some buttons that are really, really annoying next to other buttons. So if you fat figure them, then you actually have to write what you just wrote again, which is what I just had to do. So it was between different schools in Estonia. Oh, that's sick. Is it like high school, or that's really cool. So you have like you're a part of the chess club though, right? Like at your school. At the view frustum. So this might actually only be like 5 to 6 chunks, right? And so LOD 0 is at 64 cubed, and then LOD 1 is at 32 cubed, LOD2 is at 16 cubes, but I think that we can probably even push these down further. I don't think that 64 cubed is actually necessary. I feel like we could probably get away with like 52, 24, 12, or even 10, right? And that would make memory a bit easier. Now we do lose the whole, you know, powers of 2 sort of thing we got going on here, but I don't know if that actually matters at all. I don't think it matters at all. In this case, you know, there's no padding sort of thing. There's no like sim sort of thing going on. I think we can definitely get away with this. Yes, you're in a chess club. Yeah, that is sick. I don't even think we had a chess club at our school, at my high school. We had like a bunch of weird clubs. We had like robotics. Like I was in the robotics team or whatever. I was, guess what? I was the programmer. And then we had a science Olympiad, which I was into. I got like a gold medal or whatever at some point in that for one of the things. I don't fucking remember. And we had, what else was I a part of? We had D&D club, which like, I think we went to D&D club. Just I showed up once and then we never went again because I don't know. Like it's impossible to play a game of D&D with that many people. How do I get a job with no degree? I'm doing a polytechnic degree in electronics and telecommunication engineering. Help me, mate. Yeah, I remember you were telling me about your classes and stuff. Yeah, I mean, I don't really know myself. I'm struggling with getting a job myself, you know. Of course I could get a job like, you know, like in a restaurant like I always have, but it's hard without a degree, especially if you don't have work experience. I think that work experience matters so much more. So since you're in college, then get an internship, like ASAP. 100% get an internship. Doesn't matter if it's not paid. That is worth so much more than anything else, like to get your foot in the door, right? Every single job is asking for work experience, right? Because recruiters, people at companies, like any business owner, doesn't have the time to look at your portfolio, right? They're just going to look at what's in your portfolio, see, okay, he did this project, he did that project. They're not actually going to look at the code, right? They're just going to look at those projects, and then they see your previous work experience, and then they're like, okay, this guy's valid. You know, these are good projects, this. If you don't have that work experience, they're not going to take the extra time to go through your portfolio, through the code, and see that you know what the fuck you're doing. You know, people just don't take the time to do that. I think that's bullshit, but that's how the job market is, you know. So, hey Tools, I'm alright. I've been working on the collision for this. I kind of want to show you what it looks like, but it's kind of hard to show you what it looks like right now because it's kind of hard, but I can whip something up real quick. It's just the memory is just sort of weird right now, so let me try to like hard code it so that we can show you what it is all about. Right now I'm just basically making the chunking system so that when you walk around, like different chunks have different levels of detail, right? So I just want to bind buffer for the 0, and then we're just gonna do the chunk that you're on right now. Hopefully that works. Okay, well it isn't working. Well, that's kind of a bummer. Yeah, honestly I don't know why. But I am kind of in the middle of working on it. Huh. Bind buffer base. I mean, yeah, this should just work, but there's probably something that I'm not really seeing with it. Maybe I need to load chunks once. I did set data inside of it. I've joined midway through this project and do not understand what's up. When is your new project starting? Okay, so this is it, right? So as you can see when we walk around, it right, and so the most recent things that we did with it was making the collision. But yeah, obviously there's going to be no more work to. Yeah, the collision is still sort of, you can kind of get stuck in walls sometimes, but I think it's alright. So basically this is all like generated in real time using fractional Brownian motion. Eventually I want to have more, like, you know, obviously the idea is for like different planets to have different like materials. But yeah, obviously. So it's very memory intensive, right? Because this is a lot of potential triangles, right? Even though we don't emit that many, it has a potential to have, like, you know, I don't even know how many, like, it's like 64 cubed times 15, right? For a single chunk, which is massive. The further away chunks we can kind of get away with stuff, but the close chunks are like obviously pretty hefty, and we're kind of running out of VRAM, so that's kind of, I have to like pack the normals into integers, and that's what I'm going to be working on. Dev demos never work, yeah. So anyway, knowledge. So what we're working on is a space simulator. So I have an n body thing with like hundreds, like not hundreds, but tens of thousands of particles out in space, but we can't see them right now because we're on a planet, right? So this is like half of it, and then the other half is like actually in space with it from outside. I see you can already walk. Yeah, so that's kind of the goal with the collision. I'm happy with the collision. It's just hard because we have arbitrary spaces, arbitrary things. So we don't actually resolve collisions against a triangle. We calculate it all in real time using the density field. Which is, so it's a different type of collision than it's in a game engine for sure, because we're basically calculating the normal of this based on like a ray march, so it is possible to sometimes get stuck in walls like that. You didn't respond to my question? Oh, you can join from the start? Yeah, I mean, we have, I have videos going back, or streams going back when I started it, you know, like a couple of weeks ago. So anyway, so yeah, obviously the chunking system has to be a bit different though than this. So instead of doing the distance, the way I was deciding where our camera is, which chunk we're in, is the distance. We don't want to do the distance. We don't want to do the distance. What we want to do is we want to make a bounding box for each chunk, and then check if the camera is inside of it. We want to check if the camera is inside of it and create a bounding box for each one. Yeah, so that's what this is doing. It's just like, if the dist is within something, then we have a cam chunk, and if the dist is greater than some amount, we want to free it. Another thing is that maybe we don't want to have SSBOs per, it's technically is overhead, right? Us setting this buffer to 0, right? But the idea behind this was to absolutely have 100% control over our VRAM. Because if we don't have this control, right, then it's that maximum that we talked about earlier, right? So 127 and then this, right? So with 127, we're looking at about like 500 megabytes plus, which doesn't sound ridiculous actually, but considering we have the particles stuff and all that, this actually starts to become a kind of a concern. Am I making a game? I don't know if it's really a game. I mean, it's like a simulation sort of thing, but I mean, like all of my projects, I'm gonna put it on my GitHub, and you can, you know, download it from my website. Yeah. If you're interested in it. But if it's, you know, in terms of like any gameplay elements, I'm not really sure. I don't really consider myself like a game developer per se. I just I kind of like just consider it like art, you know, not really thinking about like, you know, entertainment, I guess. Inspired me to stream. Oh, that's sick. Still not 100% sure if I should do it. Oh, that's sick. Yeah, that's exactly what I have. I have a capture card as well, so that's exactly how I stream. But yeah, so my computer is so old that I don't even need a VGA converter. My computer actually has a VGA, and my monitor has a VGA, which is pretty funny. But you meant to go to the capture card. That's what you meant. Yeah. Got it. Yeah. Yeah, it was pretty funny because so I had this computer, right, my old computer, and I wanted to hook it up to a newer monitor, and then I realized that this old computer, I like moved the whole setup around, and then I realized that this computer doesn't have an HDMI output, and I was like, are you fucking serious? Like, that's crazy. It's just like very funny for me to see. Yeah. Yeah. I didn't even consider that, and I like moved like all the monitors around and all the cords around. That was fucking funny, man. Yeah, so yeah, like I was saying, if this is 64, then this ends up and this is 32, then this ends up being like 500 megabytes. It's pretty high. That is pretty high. We can actually bring it down to like 400 if I pack things into unsigned integers. So right now what I'm trying to decide, like in my head, right, is if I want to refactor this so that we don't have SSBOs per chunk, because that would make it so that we can't actually get rid of the memory. So we would have to basically allocate this much memory once, and that's it, right? So this would be us allocating like 600, 700 megabytes of fucking VRAM, and then just saying that's necessary, when only like maybe half of it is in use. That might be what we have to do, because so there's like technically we don't have to do that, and we could do it on demand like I'm doing it. However, the driver overhead for that is insane. This is insane. This driver overhead is insane for clearing these buffers, for freeing them. It's basically malloc and free but on the GPU, which is like more expensive, like more crazy. So I shouldn't have done it this way, but I was running out of memory and I wanted to see like maybe we can get away with more chunks if I do it this way. I think the solution is compromise a little bit on the resolution, pack the vertices into integers, and see where we're at then. possibly turn the resolution down to here. Because, yeah. That's what I'm thinking. And we just have one buffer that does this, one buffer that is this, and one buffer that is this. So 3 different LODs, like buffers that are all have their own resolution, right? So LOD 0 res is going to be 52. They don't need to be like powers of 2, so that doesn't matter at all, because I don't think it does. Maybe technically for some, I'm not really sure how the GPU optimizes stuff like that in terms of cache, but it certainly is better than just using a power of 2, or like just using 64 just for the purpose of having it, like, you know, because when it comes down to it, 52 is going to be such an incredible like amount of less memory, right? And so that's what I'm thinking. That's what I'm thinking about it. I would go and calculate it, but like it takes so long to calculate it. Sure, here, so let's do some calculations on what it is before we commit to this. So we do 52 to the power of 3 times 15, because is it Emacs? This is actually Helix. I kind of wish I had the patience to learn Emacs. I feel like I would enjoy it, to be honest. It feels like something that I would, you know, it's definitely like my kind of vibe. Like Soding uses it too, and I'm a big Soding fan. However, like learning it has always been, I've like tried it, right? But my muscle memory is so against it. Yeah, this is actually Helix. I love using Helix because it's very fast and this computer sucks. That's my argument with it. Like, NeoVim is too slow, but Helix is like super fast. I can have like 10,000 line files open and there's no lag at all. Even with like searching through very big projects, you know, there's no lag at all. You know, it's very fast. So that's what I like Helix, but yeah, I'd probably like Emacs as well. So this times 15, right? Because 15 is the maximum amount of vertices for each point in marching cubes, right? And so we get 2 million. Right, that's in bytes. Yeah, so 2 million bytes, right? Yeah. Switch back from Helix back to Vim. Yeah, I mean, I was talking about NeoVim. On Vim, they're pretty much similar. I think like Vim would probably be faster, but I was really talking about like NeoVim with like LSP, like plugins and stuff. Like once you have like LSP and Tree Sitter and all this stuff on NeoVim, like it just runs like shit, you know? And so that's the good thing about Helix, is that you can still have those things like LSP. Although obviously I don't even like the LSP stuff all the time, but it is sometimes like useful here and there, you know? But I've also used Vim too, and it's really, you know, it's minimal and cool, yeah. But yeah, it's definitely gonna run, you know, Nano and Vim are gonna 100% be faster, yeah. So that's 21. Really, that? Alright, that's one. That's one, yeah. That is one. That's actually not bad though. 21 megabytes. That's not bad for the first. Unless I'm calculating that wrong. Maybe I am. Oh right, I didn't actually multiply it times the. Oh fuck, I fucked it up. How do I go? Can I do? Okay, so this was supposed to be times the size of vertex, which is 32, so 67 million bytes. Yeah. 67 isn't bad, actually. So 67, and then you would be like, so 67, and then probably like, I'm thinking like ratio wise with what we had before, there would be 67 and then like 200. So now we're at like, yeah, we're really low now. So now we're at like 300. 7, yeah. So now we're at like 300 megabytes probably with everything. Maybe even less. Maybe 400. But I think like anything in the range of like 200 to 400 is possible for us to do. I think it's possible. Like every computer that's able to run this stuff with this amount of compute stuff should be absolutely fine with us under 2 gigabytes of VRAM at least. So that's fine. Making that a thing. So okay, so instead of density SSBO max chunks, we should have 3 for different LOD levels, and then have a type def for LOD levels. I don't know. I hate either way of writing these nowadays. Okay, so we're gonna just index it by that nice and cleanly, and then we're just gonna of course have LOD max at the end, nice and clean. And now we need to go here and replace it. Now the indirect buffer can stay the same because that's per chunk still. However, the density SSBO is going to be allocated just once, right? Like we just talked about. So here what I did is I just gen the buffers to max chunks, but now we're instead going to go to LOD max, and we're going to bind them and just we actually have to do them separately, I think, yeah, because our defines obviously aren't in, I mean, technically you could put them in an array. Yeah, what would be the most idiomatic way? Because yeah, I'm eventually going to have to, so for each chunk I would have to have an if statement, of course, that just says, hey, if LOD is 0, then our size is this amount. To avoid that, I could just instead put them into an array previously, right? And then we wouldn't have to have an extra instruction there. Why couldn't I think of the word fucking instruction? What is wrong with me? So instead of having that instruction, what we should do is we should just have a global array that just has these in an array, right? So that's what I'm gonna do. I'm just gonna make we can just make it static const LOD res, yeah. Alright, there we go. And so now we'll just index into that instead of these, and that'll be very neat. Okay. Okay, so we're just gonna do them. Oh, actually we can. This was the whole purpose. Now we don't actually. We can just do this like this and just calculate this here. It's not gonna be size of density data, right? But there's going to be. You can just do this. We can calculate the size of this on the fly. But calculating this on the fly isn't going to actually change our struct on the CPU. So we could calculate the size on the fly, sure, but that doesn't actually mean that our struct on the CPU is gonna fall into the same thing. Yeah, I was thinking about this earlier, like what if we tried moving the density calculation to the CPU, like if that would make it faster because we could multi-thread it and stuff. And in that case you would definitely want you would want to have a struct on the CPU that has the layout just for, you know, convenience. Without having to do all that arithmetic to, you know, convert it to a certain size and shit. Yeah, I think that we're going to not do that actually. Yeah. Like, let's not do that. Let's actually just calculate it on the fly. We don't have to calculate it on the fly, per se. We can actually just, like, calculate it here. Well, we actually can't. Can we? Okay, we'll just have them externed. There's no really, like, you know, idiomatic way to do what I'm trying to do right now. So I think we just extern LOD LOD density sizes. Yeah, just so that we don't have to calculate them again and again. And then we'll have LOD vertex sizes. And we'll just put them here, and then we'll just calculate them on the fly. Hello, just found about your channel. Is this a series of videos? Yeah, I have streams going back about like a week or two on this project, probably about 2 weeks, yeah. Before this, I was doing a project on Windows XP, doing like a cellular simulation with, you know, mass conservation sort of thing. And then before that, I was doing the chess engine. And before that, the longest project was the game engine, yeah. So we can just calculate this on a init, right? So that's what I'm gonna do. We'll just calculate it right. Where's a good place? We'll just calculate it here, sure. We can just actually calculate it right here because this is when we need it. So LOD density sizes I is going to equal right. So we need LOD res I times LOD res I and just add 1, right, to all of them. You got myself a subscriber. Thanks. I hope you enjoy the videos. I am live very often. Okay, so this is the LOD density size, and then we need the vertex size. Actually, so let's. A good question. We don't want the bytes in it. Yeah, let's not have bytes in it. Vertex sizes. So how does one learn this? I can't comprehend how. Do you know what to do? I think you just spend many hours of your life inside and staring at a screen. To be honest, you know. I don't think that it's I don't think coding is about skill. I think it's about experience, you know. I've like basically, you know, dedicated my life to programming, right? And so that means you have to kind of sacrifice a lot of other things, you know. And so I think there are you know, pros and cons to that sort of thing, right? So that's what I always say when people ask me about it. Is that it's all sort of, you know, trade-offs, right? But I mean, if you do wanna learn, you know, about it, then I feel like, you know, you just have to spend time doing it, you know. So you just have to spend time doing it. There's no real secret, you know. No real secret. And then we have actually just 2 floats at the beginning. Oh no, they're 2 ints. But those are left over. Oh no, they aren't actually, because we have to actually change this SSBL layout now. This layout now has to be. Can I get what you're doing when I read it? I know the basics. Put it together masterfully. Thanks. I don't know about all that, but I appreciate that a lot. I appreciate that a lot. Oh, the problem is that these density SSBOs need to all have varying sizes that are defined. Oh shit. Yeah, that's actually a big problem. That's actually a big problem, yeah. That's actually a massive problem, yeah. Yeah, that's a massive problem. Okay, so if you want to know what the problem is here, okay, so we have these 2 arrays. These 2 arrays that, you know, one has the density values for the scalar field and one has vertices, right? However, our density data has varying sizes based on the level of LOD that we are calculating, right? And so there are 2 so this can't be max density resolution. It's one of 3 different resolutions depending on LOD, right? And so you would like to just unsize the array, right? However, you're not allowed to do this due to GPUs being GPUs. You can't actually do this. What you would have to do is you would have to put this in another SSBO and waste another binding slot. that would be fine. However, we also have these which need to go to a varying. We could actually just standardize these at max chunks. It wouldn't be that bad. The reason why we need these at varying resolutions is because of memory. We want to save memory layout, right? So basically each LOD would have to have another SSBO, right, to do this one. Or maybe we don't even need chunk vertex offset anymore. Yeah, we don't need it because we literally are just... Oh no, that's the amount, yeah. Would I use AI? No, I don't really use AI. I sometimes, like, when I, like, am at a loss to, like, how I'm going to, like, move forward in a project, I sometimes, like, consult AI as, like, you know, some sort of encyclopedic, like, knowledge on, like, you know, I'll, like, propose to it, hey, I'm thinking about this next design for, you know, this or whatever, and then if it gives me garbage, then I don't use it. It very often gives me garbage, but sometimes it genuinely, like, oh, I didn't think about that, maybe that means something. But would I use, like, it to actually, like, write code for me? Absolutely not. What's really the problem here? Dynamic allocation. So the problem here is that we have different LOD sizes, right? So this max density resolution is actually only at the maximum LOD, right? So this is max density LOD 0, right? And then this would be max density LOD 1 would be 32, right? And so we have this SSBO here, right? With these unsized vertices. Basically, because this is at the bottom of a struct here, we can unsize this, and so when we allocate this buffer to the GPU, it just allocates however much memory we gave it. However, if you have another array on here, you can't unsize it, obviously, because then it wouldn't know what's the sizes of the arrays, right? And so this has to be a compile time defined constant size. So if we want to have two unsized arrays, we now have to have two different SSBOs here, like this, right? And so this is how you would have to do it, right? For each different LOD level, they have their different ones, and now they can be both unsized with their own LOD size. That's one option, or we can have it the other way around, right? Where we have three different SSBOs and each have their own one, and we bind them to different places, and you know, this one becomes LOD 1 or whatever, you know, and so they just go down like that, right? However, you would have to pass in a uniform to tell us which one we're referring to and all of that, which would really, you know, there's an overhead to doing that, right? And also we would be taking up, you know, valuable binding slots in terms of SSBO. So I think the most kind of the most idiomatic way to do this would be to put them into two SSBOs, and each LOD level has two different SSBOs, one for the density field, one for the vertices, and then this one holds the drawing counts for that for that one, right? And then it goes to max chunks. Yeah. So yeah, that's kind of my many things. Yeah, no problem. I also thought about like just keeping density on the CPU, and then just uploading it to the GPU, but you would still need to upload it to the GPU, so that doesn't actually fix the problem. So we actually started it with hold on. We already actually have this marching cubes data. Oh, but that's just one SSBO, of course. Okay, so to save memory, we have to do it like this. That's the only option, really. And it does suck, but that is what it is. I don't really know what to call this. I think just density vertex data. And we're gonna have to find binding slots for this. Unfortunately, I think that we already have 11 in use. Let me check binding. We can check it here. Position SSBO is this. I don't even know where I use position SSBO. We don't use it. We don't use it. Okay, so let's just get rid of it then. From that binding slot. Back after some Googling. So you're making a game with C, programming language, and OpenGL as the engine. It's not really a game, it's a simulation of space and planets and terrain generation, and it's basically an n-body simulator, but you can go down onto planets and walk around on them. That's the goal. I did make a game engine, yeah, a while ago, but now I'm kind of like more in the vein of like weird experimental like simulations with math and stuff. That's cool. Thanks. Thanks. Okay. So we still have this actually. It's just this is obviously just going to be the density SSBO. We do have density SSBO LOD max, and that's fine, but now we also need density vertex SSBO. So that's what we're doing. Okay. So now we need to do the vertex sizes, and so of course this has to go times max LOD.
Like low prices in every aisle, plus you can clip and save more with digital coupons in the app and earn fuel.
Okay, I need to figure out how much I need to define actually for how much the max chunks per LOD like that's necessary for us. So max chunks LOD 0 is going to be 1 for now, and then max chunks LOD 1 will be 27 to get the surrounding cube, and then max LOD 2 we're gonna have, I don't know how much, I just want to play it safe, and so we're just gonna put it at 10 because we don't want to really worry about it, but okay. So that's what this is going to be multiplied by. Chunk max. I said it was max chunks LOD. Why does it not come up? Hey, what's up, Kiel? Nice to see you. Oh, I have to put this, of course, in not in a define, of course. Let's just do it here. Oh, I called it channels. Okay, so that's good, and then we'll just have this down here. Okay, so that's that, and now the only other thing inside of here is this chunk vertex offset, and density data has 9, which is just density. So we need the 2 buffers now. Hold on. So this is not going to be size of vertex. This first one is just the density. So size of float times LOD. Density size is I. Okay. And then this one is going to be the bigger one, right? So we have to do the size of int times max chunks LOD. Oh, actually this has to go to max chunks because that is sized. Right. So that is sized, so this max chunk chunks always has to be the same. The good thing is that it's just integers, so we could just leave it at 120, and now this is never going to bother us again. And let's just make a max chunks 120, and we never touch it again, right? And this is max chunks per LOD level. Okay, so this is just going to be times max chunks, and then we just have the LOD vertex sizes I times the size of vertex. That should be absolutely fine. And we need a gen buffers and bind buffer for that second one. Density vertex SBO. Okay, so now our buffers are set up, which is nice. Now all we have to do is bind buffer. We don't want to bind buffer base. We want to bind it depending on the LOD level. So we're not going to bind buffer base yet. Only when we do the actual meshing, when we derive the LOD level, that LOD is not in here, so oh. And obviously these sizes aren't in use anymore. We're just going to derive everything from LOD level. The tricky part now is that chunk IDs need to be per LOD level. Right. That's tricky. Because this chunk ID is obviously can go up to 20, but then like up to like whatever, right? But then it needs to be offset by the amount of, yeah, fuck. That kind of throws a wrench right into my plans, to be honest. I'm talking about this chunk ID, by the way. This obviously goes to LOD level, right? But this chunk ID that's used obviously is different because it's not a local. Nowadays Trump is hallucinating like AI. I don't know if that's just nowadays, yo. That's I think, to be honest, everyone I've met that makes over $100,000 a year hallucinates a lot. That's what I think. I don't think it's just that guy. Shit. Okay, we need 3 different arrays, one for each chunk LOD level. There's no way around it because we need local IDs and not obviously global chunk IDs, so these chunk IDs need to be obviously per level, so kind of fucked. Oh, also the indirect buffers. If I do local chunk IDs, then the indirect buffers also need to be indexed by LOD level. It would be like indirect buffer LOD level chunk ID. Fuck. Yeah, that sucks. So now you're looping through each LOD level, through each chunk. Yeah, I mean, that's fine, I guess. Okay, this is gonna get complicated though. Alright, it's time to get complicated. Alright, so where is my array for the chunk data? Where did I put this? I put it here. The simplest way would be to do this. Yeah. Would be to do that. And that way you always have an internal chunk ID that you take in here. And you would need to obviously do indirect buffer the same way. This is getting complicated though, to be honest. This is getting very complicated very fast. And I feel like it's not gonna stop getting complicated now. I feel like we haven't even hit the complicated part. So, okay. Fuck. We need to also copy this into every single shader that uses it. So that's something else I have to do. Okay. What else is this indirect buffer? Okay. Okay. This is becoming very complicated. So, why do I have... Okay, so it's here. So instead of just looping through this, we need to loop through all LOD levels. And then go to max chunks for all of them. You don't actually have to go to max chunks. That's just what we could go to LOD max chunks LOD for L, and then just go LI. And obviously the indirect buffer for L I. I think at this point we just have to refactor everything and just not think too deep about it, because then it's gonna take forever. We just kind of have to write the code, and if it's fucked, then we have to, you know, cross that bridge then. Okay. The problem is that there's really no way, that's the problem, is that there really is no way to, there's absolutely no way for us to determine, like, if this is gonna work or not. We have, like, literally no way to know. For now, so my idea is just LOD, so we just take in this constant for LOD, and then we just set up the size. Yeah, so int size equals, let's just put it down here because it'll be down there eventually. LOD LOD res for LOD level. There we go. Okay, so this should all work as long as our chunk IDs once again are local, but that's what we're gonna work on now. So by local, I mean for each LOD level needs to start at chunk ID 0 instead of just starting at, you know, the global offset, right? So load chunks is obviously going to have to change a lot. I'm almost considering just commenting it out and then just like literally ignoring it for now, and then just hard code the chunks just to test them before we have to cross that bridge, right? I just want to make sure that the buffers are all bound correctly and all of it is ready to go before we go into that, because God knows, like, one typo here could be really disastrous. Really disastrous. Okay. We have another error. This is reading out, right? So this is just for debug. Okay. I think we're ready to hit compile and see. I just kind of have to set up a test scene, I suppose. I really want to just like do at 0, 0, 0, and maybe here, I guess. And this will have the ID of 0, just to test out. that this is working. Let's make it LOD1. So we probably have some compile errors. We don't. Okay. Surely we do. Oh my god. This printed out a lot. Macro max chunks redefined in density.comp. Okay. Oh fuck. Oh shit. Yeah, this max density resolution needs to not be that, obviously. Actually, this is just U size. This is actually just U size now. Yeah. So nothing to really worry about there. Okay, so we do have to do this again. Except obviously this is just the size and not the max resolution, it's the local resolution, right? Atomic add int, oh yeah. Okay, and then indirect.comp. Right, we have to go. And then we have to do this offset. It's the same as this. Hunk I. Okay, we have a couple more things. Indirect U size. Oh. Oh, we never set them as not free. I see. Maybe. Okay, well let's hard code it for now. So we have 0 and 1 that are drawing. So we're just gonna set this like chunk data for LOD level for chunk ID. I would love to see something getting drawn. That's what I would love to see, personally. Oh, we don't actually. We need to bind the 10 mesh vertex density vertex SPO. We also have to make sure that both of these are bound during the mesh generation, which I don't think we did. No, we did not. Also, this is supposed to be for L, not I. Okay, we got it. Okay, good, it's working. Very interesting artifacts. Oh, I know why it's weird. It's because we aren't clearing the correct thing. We aren't clearing the vertex count at the beginning. We are only subdating what's in the density SSBO when we need the density vertex SSBO. Whoops. God, this song always reminds me of Pokemon. So I love Pokemon. You know, my sister and I every day we play the Wordle for Pokemon. Super fucking nerdy, I know, but dude, I love Pokemon. I wish that I could play it. You know what I mean? Like I'm kind of too old to enjoy it. It's kind of like too low skill, you know, of a thing. But like, you know, not to like, you know, diss anybody who's like, you know, in competitive Pokemon. I don't play competitive Pokemon, but I mean, I'm just saying. I just feel like, you know, the other day I was like, you know, bored in bed and just like didn't want to work on anything, and then I was like, oh, I'll play Pokemon, man. It's like so fucking boring, dude. So it's like not. They're good fan games though. There's good fan games. You know, that is good. But I mean I've played them, and now it's kind of hard to like replay them, especially Reborn is like fucking actually like 90 hours long. Like I tried a run of it, ice only, a while ago, and then like I just got bored like after like the 5th gym, because I don't know. The first time you play it, it's like the story is so good and it's like, you know, awesome, but then once you know like all of the secrets and the tricks and shit, it just like kind of ruins it. Like it's hard to replay that game. It's my favorite Pokemon. Yeah, that's a good question. I like Frostlass. I also like I like Girafarig too. and my computer just decided that that was it. So yeah, the overheating is definitely annoying in this dumb hunk of metal. Not much I can do about it. Okay. So that works. The reason why it was offset from the camera is just because I made it offset from the camera. Alright. Okay, so now we can get back into the load chunk function, I think. I think we're ready to do it. Yeah, if the pipeline works fine, then we can go back into the load chunks file. Yeah, this is gonna be the hard part though. Heard about some interesting book names like Dracula versus the German guy. I'm not sure what the German guy is. This up. All right, peace out. Thanks for hanging out. Have a good day. Fuck, man, this is not gonna be easy. Right. So I need 3 different arrays. That's what I was doing. Oh wait, no, but I have 3 different arrays. It's in one array. So I'm wondering if this should be the final system or not. I feel like this system is just super naive. I want to prioritize chunks within the view frustum, but also I want to prioritize chunks that are near the player, and I'm trying to think like how I'm gonna do that. Like, it's not easy. I think like 1 by 1 by 1 ring around the player camera is like necessary. I feel like it's necessary. So maybe we just get the 1 by 1 by 1 ring, make those necessary, put them on a list to execute, and then sort them by which ones are currently in the view frustum, and then calculate those until we run out of time in a frame. Very good idea, don't understand anything. Basically, I'm going to iterate over all of the chunks near the camera, and then I'm going to push them all onto a list, the ones that aren't done yet, or that haven't been done, and then draw them, and then I calculate them until we run out of time. But we have to keep track of time, I guess. That's what we have to do. We have to keep track of time, right? So let's get the current time right. Using this classic method, right? The performance counter. How do I do this again? I just get performance counter. And then we just try until we go over some amount. Hold on a second. Oh, it's just being a dick because of that. Shut up, indented too deeply. Like, clanged is so fucking shit, man. Like, it doesn't let me write an array like this. Like, why, man? Like, why? Like, why do you make me write it like this? Like, fuck off. Please, man. So annoying. So something like that. Except you probably want this inside of that array, I guess. Except, so this array, we're just gonna push chunks into an array, right? So let's do that, right? So let's have a yeah, I'm gonna make this too complicated very fast. The way I just like was thinking about it right now was like, we could just like have indices and then sort them based on a score. We could score them based on how close they are to the camera, how, if they're inside the view frustum or not, and centrality to the camera or something like that. That sounds really, really complicated though. That does sound kind of complicated, not gonna lie. Okay. So here what we do is we're iterating through and we're checking for which chunk our camera is in. So that's what this does. So we're just going to change the iteration here to be like this because our arrays are now nested. Okay, so we don't want to do that, obviously. I'm just thinking, like, how are we going to free chunks? How do we free them? Okay. What we could do is, for every chunk that exists that is cached, we can sort them based on how important they are. And then we can replace the ones that aren't that important in that order. Let me see. Is it, which way is it? Okay, so less than val2. Okay, so I'm trying to, what I'm searching up here is how I'm gonna do this, how I'm gonna sort. I think what I'm gonna do, right, is we'll have two different weights, right? So we'll have a float frustum weight, and then we'll have a float distance weight. And so if it's within the view frustum, then it's going to be 2. And then this gets multiplied times this, right? So it's like squared, right? So if something is inside the view frustum and it is close to the camera, then it has an extreme like importance score, right? And then we sort the chunks by that amount. And so we just we want to initialize these though. Oh wait, hold on a second. These need to be yeah, they need to actually be like that. Because we need to... Oh no, we need to... Oh. Unless we have them per LOD. And then of course, the higher LODs are gonna come first. It's gonna be more important. Yeah. Yeah, and so we'll just do this way, and then the reason why I'm doing it this way is because fuck off. Fuck off, fuck off, fuck off. Let me press the O button. Like, I keep on pressing the P button instead of the O button because my hand is just fucked up. Okay, so okay. All we're doing is Li equals I. There we go. So it's just that. We just start off not sorted, yeah. And now we need important scores. Okay. No, you can't do it like this. We did it actually like this layout. Yeah, they need to be this way because we're going to sort them, so they need to be flattened. The thing is, you need these to be in a struct. Yeah, this is a lot of thinking I'm doing, sorry, but I need to kind of think about it. Alright, now we have to do the frustum check, which I copied from my other code base earlier. I copied it here, so let's just straight up copy it. This is how I did it on the PS1. Exactly how I did it on the PS1, except of course we have to take in these planes. Six. Okay, so obviously this returns a dot, a boolean, right, for if it's within the view frustum, but it should be enough for us to get it. Anyway, we have to do this math before that, so that's what we're gonna have to do. So we don't have mat for mole. I definitely do. I guess not. Shit. Well, time to copy my own homework. Yo, what's up, bro? I definitely have this somewhere in here. I mean, I have it, but I don't want... Oh, fuck. Fine, we have to write it. We have to write it. Fine. Pain in the ass. Oh. What am I doing now? I'm working on doing the chunking system. I need to find how to get the chunks that are within the view frustum sorted first, so that we can do better chunks, you know, do the better chunks first. So that's what we're doing. I just have to write this mat4mole function so that we can get the view planes. I have to just like figure out fuck, this is like so annoying. I'm just going to like literally look it up. Yeah, but like, can I just get one that's not like an array? Like, I just don't want to do it in an array. I just like, I'd prefer not to. Just give me it with no, it's all like that. I just want it hard-coded. No, writing that would take so long. Writing that would literally take so long. Yeah, I'm not doing that. Priority queue, maybe? I mean, yeah, that's exactly what I'm doing. Fuck. Oh my god. I would have to do... Yeah, we're not doing it. We're not doing it. We're just gonna do it in this way and then like convert everything into arrays before that because I'm not doing that. Yeah, fuck it. Fuck that, yeah. Absolutely not. Absolutely not. That sucks. That does suck though, because now I have to manually convert everything into that. I need to convert proj and view into float 16. I can't just do that, obviously. We have to do it manually. So that's kind of the shitty part. So, that's cool. Whatever, man. How are we gonna do this? I have to do... Is it literally just... I wonder if it needs to be column major or if it can be fine. Maybe we can just like mem copy into it and it's fine. I mean, probably. I don't really know what if it's row or column major. So let's just do it like this. Okay. Okay. So now we need to do this. We need to have matrix add. So I probably shouldn't have closed my other code base. If I can copy it, that would be sick. I doubt that I have it, I guess. Dude, I don't want to have to write that too. Are you fucking kidding me? I have M4. Wait. Oh my god, are you fucking kidding me? I did have it. Why did I not think that why did I not find it? I had a feeling I had it. So I was like so confused. I was so confused. The problem is that this implementation is kind of annoying, but it's fine. Okay, well, now fuck me, I guess. That's annoying. Well, whatever. Yeah, I did actually search for M4 as well. Okay, there we go. Okay, now do we have M4 add? We don't. M4 sub? We don't. Okay, well that's, now we're shit out of luck. But that's actually the easy part, because we just have to add them together. So that's the easy part. We do need both, right? We need add and subtract, yeah. Oh wait, hold on a second. Oh no, it's the third row times that. Yeah. I think that's what it's talking about. Let me look this up real quick. Adding or subtracting specific rows of the VP matrix, typically requiring normalization. Right. Yeah, okay, got it. Yeah, so that matches exactly what I have. Okay, so it is the rows. Okay, so we just need to get them into rows and then just do vec4 sub, which we already have. Okay, so
LinkedIn is pretty amazing at helping you grow your small business. We cannot stop your new clients from emailing you at 3 a.m.
vec4
We
vp.a0.
and hire in one place. We cannot help you be in 3 places at once. And while we can't help you organize your calendar,
Okay, fantastic.
LinkedIn can help you land more clients so you have a calendar to organize.
Please shut
Grow
the
your
fuck
small
up.
business.
Thank you. Okay. 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 So now we just need to do this all the way down. This one is sub. Oh, I don't have vec4 sub. Ah, shit. Well, it's fine. It's easy to make it in a second. Yeah. So apparently you need to normalize these vectors. I'm not entirely sure. I should probably like go about simding that at some point, but whatever. Okay. I fucked it up, huh? I didn't rename it. Okay. What is the problem? Okay, done. Okay, we have the view frustum plates. Thank God. That was more annoying than I thought it would have to be. And now all we have to do is check the bounding box against this, and so we need a vec3 with the minimum and the vec3 of the maximum, and so that's what we need to calculate now. For each chunk we need to calculate the min and the max. So all we have to do is subtract half of the chunk world size from the center, right, to get the min, and then the max is just adding it, right, to each dimension. And so that's fairly simple, right? So vec3 min equals, we could also do this when we create the chunk so that we don't have to calculate it every frame, but just for now, it's very simple to do this. We need to get the, we need to vec3 sub the li chunk center from, let's make these permanent vectors here. Min offset is going to be negative chunk world size divided by 2. Fantastic. Nice. Okay, and now we just have to get the max offset. And now every chunk's center will just be, we're just gonna add times the min offset, and then we'll add the max offset, and then we will test if it's in the view frustum with that bounding box. Okay. We can have a bool within frustum equals A of B in frustum min max plans. And then we will have the weight, right? So we want to linearly calculate distance from 1 to 0 or 1 to okay, so the higher value, the more important is how I was going to do it, right? But that means that obviously distance is going to be higher, and that's going to be worse. We want the further chunks to be worse. So we can deal with that a couple of ways. We could interpolate between 0 and 1 and then subtract it from 1, right? And so the way I was thinking about calculating the float weight would be we linearly interpolate between 0 and 1 based on the dist divided by some large amount. Have I solved any issues? Yeah. I mean, with the chunking, not, I mean, I'm kind of in the middle of, like, you know, coding it, right? I think we can do it by some large value. Let's just standardize it to chunk world size times 3. Yeah, because that's only going to be, yeah. So we want to add +1 here because we want it to bottom out at 1, I think, because you don't want to multiply it times 0. Wait, hold on. We want to go 1 0. Yeah, definitely. Does my lerp cap out? It doesn't. No, it doesn't. Okay, so then let's not do that. Let's just literally do 1 minus that. Right, and so if dist is very large, then it's just 1 minus a very large value. If it's very small, then obviously that's gonna be fine. And so we bias it to 1. Be cam radius. What is cam radius? And then we want to multiply the whole thing times within frustum. Yeah, within frustum. +1, so that way when it's 2 it gets cubed. Yeah. So this is perfect. Yeah. Okay. Yeah, that's perfect. So the weight is solved, and now you just want to put the weight inside of here. I didn't make it a float, did I? Yeah, I made it so this should be a float that we're ordering by. Did I increase the LOD depth? There's still only 0, 1, and 2. But what I'm doing here with the weight is I'm basically making it so that important chunks have higher priority, because let's say we somehow get 10 chunks that we need to render in a frame, we can't do that. So we're making a priority queue based on importance, how close it is to the player if it's inside the view frustum, and later I might do something else then that just isn't a binary check. You know, if it is within the view frustum, maybe like centrality in terms of the viewing space, but that's going to take a bit of math, so I just want to get this done first. So I haven't gotten to the point where I'm going to queue sort these, but right now I'm just like, this is, so at the beginning of every frame we just go through, we calculate how important each chunk is, and then we replace them in that order, in descending order based on which ones are the worst. And then we do the same thing for the chunks that we need to generate in a frame, whichever is the most important, then yeah, that's what we do. That's the idea right now. Okay, so there we go. So, and that's, now we don't have this free list, or we aren't just freeing them straight up here, right? And so cam chunk is also important. We don't want to be going based on this distance, because that's not 100% always going to be accurate. We need to, obviously you would think like, oh, but the one where the camera is closest to, but it doesn't really work out that way. We want to go, that we check against the minimum of the bounding box on the top. So we want to check if we are greater than the min and less than the max. I don't have obviously like any like fancy operator overloading to do that, make that very easy. Really what you're gonna check is just every single one inside of here. So let's just write it like this. So we need do I have cam pause here? I do, right? Cam pause x is greater than or equal to min.x, and then cam pause that x is less than or equal to max.x. Fucking Christ. And yeah, my hands are not good today. I don't know what's wrong with my hands today. Okay. The trunk priority is based the distance to the camera. Yeah, absolutely, yeah. It needs to be. It needs to be. There's no way. I mean, I can also check, you know, technically for visibility at some point, but yeah. Obviously the closer chunks need to get done with higher priority, yeah. So now if we didn't find a cam chunk, this is what I was doing, then we just like spawn a chunk at the camera position. This is kind of janky, but because it needs to happen. So this is cam chunk. So obviously our cam chunk, we also need a cam chunk LOD. Since they're indexed that way now. Okay. Vision culling can be a pain. Yeah, it's not really about that, you know? Like, I already have it based on the frustum, right? And we can do a collision culling. It's hard because I don't have mesh data, right? So standard rendering techniques don't really apply here, unfortunately, because standard rendering techniques means that you have they depend on you having the mesh data in a CPU side buffer. I don't have that. I don't have that. My triangles are on the GPU and they need to stay on the GPU for speed, right? So I don't have that data to even implement that sort of thing from the CPU, right? So it's kind of like the standard techniques, I can't really do them. So that's kind of the hard part, you know? But I mean, I'll probably come up with something more, you know, more comprehensive later. But for now, I can't really. I just have to kind of do the basics and then try and see if it works, you know? I can't really. Like, technically, I know, like, on paper, what I'm doing right now is probably not gonna work out, but I need to, like, find the way forward and not just, like, you know, try to, like, sit here and, like, think about it for too long, you know? Multi-threading, is that something I can do? The problem with multi-threading is that so much of it is on the GPU, right? Where we would be ping-ponging a lot. I already thought about it. Like, in terms of us doing the density field, for example, like if we go into create new planet mesh and then we basically just like move the density step into the CPU, then we could multi-thread the CPU side things, and then we could have a thread that is literally just checking if those threads have finished doing this, right? And then when they do finish, then we go through, or this, and then when we do finish, we go to do margin cubes on the GPU. And then when that's finished, we just, you know, set up the draw command, right? And so technically this could be like, this gets multi-threaded, right? And then when this is finished, then the GPU stuff happens. However, it's not that simple, because obviously if we do this on the CPU, then we have to upload the giant fucking buffer here, right, to the GPU. So there's overhead, right, with that. Also, like, this density function happens so fast that, like, if we did multi-thread the density, right, for generating one cube, right, like, it would without a doubt take less time than one frame. So so it's not that simple, right? Because let's say we have a frame, right, and at the end of a frame we call swap window, right, and so this is 16 milliseconds, right? That's all fine and dandy, but if we're here, right, and we are, you know, doing this part multi-threading, we still get blocked by the swap window, right? So what it would look like is one thread does all of the rendering in this and this and this, then you have one thread that is checking for the jobs that are done, then you have 6 threads that are doing the density calculation, right? And so that's what it looks like. Now, would it be faster? I have no clue. Would it be a pain in the ass to refactor? Yeah, absolutely. But, you know, it's not nearly as fast as you would think, because, you know, at the end of the day, it's just parallelizing something that's already parallelized on the GPU. This is the entire density function right now, by the way, is this one line. So it's literally just that one line. And now it is doing this noise function, but like a GPU sees this and it really likes this, right? Because it can do 32 by 32 by 32 or 64 by 64 by 64 instantly in, like, you know, in a couple of work groups. So, you know, it's just as easily parallelizable on the GPU than it is on the CPU. The only problem with it being on the GPU is that GPU blocks rendering, right? So the CPU doesn't block rendering if you multi-thread, right? So if you want true async chunk loading, you could do it on the CPU. However, you are ping-ponging between the CPU and the GPU, because the GPU has to do margin cubes, because CPU margin cubes is just 100% so much slower. So you have to upload the density buffer to the GPU to do just this margin cubes, right? So yeah, it's damned if you do, damned if you don't, right? But so I'm not doing the multi-threading for the density next. I need to see how this is going to perform, and then we'll look at it later. But I don't know if it's a genuine, like, it's not a 100% solution, right? It's one of these, like, kind of long shot things where I don't really know what's gonna happen. But yeah. Okay. So now we're down to the part where we're actually going through chunks, and we're gonna push them to the generation queue. So we're going to go through all of the chunks that are surrounding the camera by our radius, and we are going to push them onto the queue. So we're checking if already done. We check the distance, right, to the center. I would actually love to do. Okay, so here's what we're gonna do. For chunk data, we're just going to change it, and we're gonna have a min and a max. I don't know why I'm calling this chunk center, chunk min, and chunk max. This is just very stupid. This makes sense to be up here. Okay, so now we're gonna just use min and max instead. Yeah, so this will just be the chunk min and the chunk max. God damn it. But trust me, if I could do, you know, just like multi-thread simmed everything, then I would, because that's kind of what I do. But I can't, unfortunately. It's a non-solution here. Yeah, so we push out by other world size. That's correct. Do I have any async code in this project? Not yet. Not yet, no. But it's going to be. It's gonna have to be. But so here's the thing. You may say, like, you know, why not have async code? It's because for the end body sim, it doesn't make any sense to have any async code. Literally everything is done on the GPU. Every single thing here is done on the GPU. There is nothing that goes on the CPU other than calling the GPU. So if you wanted to have async code like that, then you would just have one thread that does this and one thread that does the input and the rendering. But at the end of the day, the rendering is still blocked by the GPU. Like, the rendering is blocked by the GPU because it both happens on the GPU, right? So there's no room to do any of this multi-threaded because you pay the cost of moving data from the CPU to the GPU, which is a very big cost. What's the word async in these projects, in my opinion? So it depends. Like, when I was doing the linear simulation on the Windows XP thing, right, on my old computer that does not have a good GPU, everything was on the CPU, because that's the way you have to code things when your GPU just doesn't have enough cores, right? Would it have been faster on the GPU? Absolutely, right? But in that case, right, whereas on this older computer, the only way I pushed that project to where it got to, which honestly was something where I was very proud of, it was, you know, pushed to its absolute limits, was, you know, I did the whole thing on the CPU with simmed, you know. So usually stuff like loading models and physical memory data. Yeah, I mean, in this project there is no models, you know. Like, you know, everything is done in shaders. So in this project there's really nothing that can be done on the CPU other than the camera. The matrix stuff is all on the CPU. Obviously the chunk stuff has to be on the CPU. But yeah, I mean, obviously I'm doing the chunk stuff on the CPU because it's necessary. But honestly, I hate coding on the GPU. I hate GPU coding. I think it's the GPUs are like the worst thing that happened to fucking programming, to be honest. I don't really enjoy it as much as writing good CPU code. It's very, you know, it's whatever. GPUs are just so, you know, the way cache works in a GPU just makes optimizing GPU code fucking really stupid. Like, it's not hard, it's not, you know, it's just stupid. I feel like. Oh, whatever. Okay, so we want to not check distance anymore. We want to check if it's inside chunk again. So that's why we did this. We want to check the center. So yeah, this is a this is a really fucked up nested loop, but eventually the goal here is to have a hash map for all of this stuff so that we don't have to loop through it all every frame. So that's what we're gonna do eventually, but for now I don't really want to spend fucking time downloading UThash and doing that, so we're gonna wait to do that. So this is actually not this center, it's going to be that. Oh wait. Oh, we need that. Oh no, we have chunk pause, that's what it is. So this is all chunk pause because chunk pause is what is being added on every time we iterate. Okay. So if it's inside chunk, already done is true and we break. So this is what this does, is for each chunk, it checks it. So we don't want to have this on the outside. We want to have it on the inside because we don't need each LOD level for, obviously, for each one. Ah, fuck. A weird itch all of a sudden on my face. This is just Clang being a dick. Classic. If already done our chunk pause, right, we increase the chunk pause and then we keep going. So obviously we also want to know if this is the same LOD as we are currently doing. For now, let's not worry about that. Am I buffering the geometry data from the margin cube, or are they being generated each frame? So they aren't regenerated if we've already generated that chunk, right? So we just store that vertex data, obviously. But in terms of like double buffering it, no, because we would literally run out of VRAM. We're already pretty much capping out VRAM with the chunks that I am going to. I want it to be so that you can see far into the distance, right? So double buffering, we did the math earlier. We're already going to be like, with packed vertices, we're going to be at like 500 megabytes of VRAM already. So that's not with any LOD2 really. So yeah, I can't double buffer it in terms of like us having, you know, one buffer and then we render to a different buffer and then swap them. Can't do it. Already did the math on it. Can't do it. It literally require double the memory, and also the benefit isn't really there for us at all. But yeah. So right now what we do here is that we look for a free chunk. So all of this part isn't here. So all of this part is gonna go down here when we actually, but right now what we're gonna do is we're just gonna push this onto the jobs list. Also, I'm starting to realize that oh yeah, obviously the free chunks are going to be 0. Yeah. So yeah, I was wondering here with this at 0 if this is gonna cause some problems, but naturally if a chunk is already free, it's gonna have a score of 0, which is the lowest score that you can have in terms of importance. So that's fine. The jobs having a score of 0 makes a lot of sense. Yeah, that's fine. So we want to score the jobs exactly how we did the freeze, I think. Yeah. We want to score them in the same manner. We don't really know what the LOD level is. We should be calculating the LOD level here. So we can do that. I already had the calculation somewhere, but I don't think that the LOD calc is correct, but we should be doing it. Where is this? It's over here. So this was what I was thinking. I don't know if it's correct. I should probably like actually do the logic by hand right now. So it's gonna start at 2. But I don't know about like this to the center necessarily. I just kind of want it in rings, but the way I set this up is kind of hard to define if we're in rings or not. Yeah, we have chunk pause, so we could have chunk pause to start, or chunk pause to the center pause. We could have vec3 center pause equals You probably don't want to do this later on, but we need to do this for now, because we need to find distance to whatever the center is. So if our distance, Yeah, I wish that we could easily find the ring around, right? Fucking, there's a scary bug outside my window, sorry. So we still do need to find dist, I think. So if dist to center is less than chunk world size, I think we just like subtract some epsilon just to make sure. Yeah. If the dist to center is less than yeah. I think that that's fine. Okay. So now we have our LOD level, and so we want to be testing that as well. So if LOD level doesn't equal this chunk data's li.lod, then we need to maybe we set a flag and then that one has to be replaced by that one. Yeah. Yeah, I want to have it so that the ones that are updating LODs are prioritized last, I guess. Or like not as heavily, right? That was my idea here. However, I need some way to, I guess, cache which chunk needs to be replaced, right, by which one. So I could just keep a array parallel to it, or I could put it inside of chunk score technically. And then when we get to them, when we get to them, then we check if we just have an int replacement index. So each job has an index that it needs to replace a chunk, a specific chunk, because you obviously can't have two chunks with different LODs at the same location, right? So I think that's how I'm gonna do it. However, the annoying thing, which kind of sucks, is that you have to do if updating LOD. We have this as an int that is -1. Updating LOD equals shit, you need both an LOD level and the updating flag and the replacement index. So you need, yeah, so now this is becoming a little bit yeah. Technically speaking, to make this a little bit easier on the GPU, right, we could use uint 80s for all of this, and that'll be easier for it to copy, because once again we are going to be queue sorting these, so very important for the struct to be as slim as possible. Oh, you kind of wish that the score was a int16t, but I mean, us doing that kind of would suck. I don't know. So that's that. So if updating LOD doesn't equal then we need to go to jobs, indexed by L times oh yeah. Oh wait, no, we need to have our own, so this is going to be by our own LOD level that we calculated, and with our own chunk index. But we don't have a chunk index because we don't have one yet. Okay, well then maybe we just keep a running count of them. Yeah, maybe the jobs don't have to be indexed in any particular way. Yeah, so let's just make the jobs a flattened, well, we already have it as a flattened array, but we can just do yeah, we just do job count like this. I just index it like that because we don't obviously have any index for them yet because they haven't been slotted in. So job count dot replacement LOD equals updating LOD level. Okay, so that's that edge case taken care of. Obviously at the bottom here we want to go job count plus plus, yeah. Okay, so this is what we were going to do actually, right? So we were going to score them, obviously, and so this is going to be indexed by job count. And unfortunately, so we don't have an index, but we do have the LOD level. And the min and the max of it we want to calculate, obviously. You wish that you could put that inside of the job struct so that we don't have to calculate it again later. That would be sick, but unfortunately that's way too much memory for us to deal with. That's way too much. We're never gonna get away with it. So yeah. Okay, so now we're determining the weight. Oh. Okay. Never mind. So we will have jobs data on the CPU here. We need, so jobs actually is just an array of the scores that we are going to queue sort, not the list of job data, which will have a different. Actually, we can just have it as chunk data. Yeah, so we'll have this struct is what we will sort, and then those indices will point us into here, which will have chunk data, job data. Yeah. So that's where we're gonna be writing into. Actually we want job data. We want a new struct. Because we need this in it. And that index will point us into here. And in here we'll have the vec3 min. Or maybe we just add this onto chunk data. I feel like that's what I'm gonna do actually. Now is it necessary for every chunk to have that field on it? Absolutely not. However, it does keep us from having to copy a bunch of shit around. Because now we can just like index into chunk data, of course. Okay, so job data, job count. So, and then jobs goes, you get the LOD here, and then obviously jobs, you get the score. And then the good thing here is that now job data automatically gets the min and the max. so that we don't have to worry about calculating it again ever. So, and then this is the chunk pause is the center, and other than that, I think that that's pretty much it. And then when we, I don't know if active is necessary, but when we sort by score, then we're only going to check the index and the LOD, and then just execute the jobs based on the job data that we have. Yep. And obviously, we need the index. And now we just queue sort both of them by but in descending order. Does it return a const void pointer? I can't remember how to do this. It returns int, right? Only if you have ints, right? Yeah. Do you have to return the actual struct type, or can you just do yeah, you just return an int. Okay. I'm just refamiliarizing myself with it. Okay. So it's minus. It's b minus a. Okay, got it. So I think this is how you do it. I think you can return a float. I think. Oh, okay, got it. So you have to, okay, got it. Okay, so the order is, if it's greater, you return 1. Okay. Got it. Okay, so now we just have to queue sort both of them down here. We could also do a selection sort. Actually, it might be faster to do a selection sort. I could copy the boilerplate for that technically, but I think just for one array of frame is probably fine. And we don't have that many chunks actually. I have like a maximum of like 120. It's the element count. So I'm just trying to think if I should be sorting to. Okay, so it's just being a dick, but okay. This is something that I don't miss about working with fucking clanged. Like seriously. It's like one of the most annoying things. It's like, it's cleaner to have a fucking indentation that isn't 3 layers deep. Like, why do you have to have this? Like, why? Now it looks like shit. Whatever, man. It's fucking lame. Okay. So now that they're sorted in descending order, meaning the highest should be first, I want to just print them out. Just to make sure that we are coding properly. Okay, let's call the goddamn function and see. Alright, we're not rendering anything, I just want to see what the output is going to be. I gotta get rid of this shit. They all have the same score. I gotta get rid of that debug, so let's just do that now before I start crashing out about it. Where the hell is it? Alright, get rid of it. Huh. Okay, so all of them were the same exact score. Trunk pause to cam pause. How are they all the same position from cam pause? Oh, because I got rid of that. Okay, there we go. So, we are ordering by importance, that is true. They do end up in buckets, kind of. What I'm interested in is why one isn't at the absolute top, because one should be exactly at the center. Let me just make sure that the math is correct here. At 0, 0, 0. Where's 0, 0, 0? Where is 0, 0, 0? Am I okay. Okay, why are we not emitting one at the center? Oh, no. Ugh. I'm so confused. Did I automatically create one? Already done. Already done. I don't create one, right? No. Oh, maybe we, oh. There we go. I was iterating over too much. now 0, 0, 0. You get a weight of 4, and therefore that one's going to be first. Okay, so there we go. We have our priority queue. So that's working. Let's keep printing them out just to make sure. So now, how do we actually do them, right? Like, how are we gonna do it? Well, we need to loop through the jobs in the freeze in this order, and now do them. And then keep a count of how much time has elapsed, and then if we're over a certain amount of time for a frame, then we just stop. That's the simple way of doing it right now. So we're just going to loop through the job count and do it. Yeah, I'm wondering if... Oh wait, we want to compare the freeze in ascending order. Yeah. Okay, got it. I just did the exact same thing. I just did the exact same thing again. So for now, I'm not going to worry about this limit. I'm just going to do... I'm just going to go and do it, I think. So all we technically have to do is this. So we just do job data J, or we just do LOD. And the chunk pause is going to be job data index dot center. Right. And then the chunk ID is going to be the freeze index by I dot index. Oh shit, but there's no guarantee that that index is within our LOD. Shit. I could loop through and then find one that matches to our LOD. And then change the active flag on it. Yeah, I think that's it. That's what I do. We just loop through the list, find the matching LOD to this LOD, then use that free thing, and then we make it inactive. Hey, what's up, Frumpy? Hope you're doing well. So that's exactly what I'm gonna do. I'm just gonna loop through the free list. Zero. You want to loop through all of it? The active thing, the active flag has to be set to true. It does get set to true, and so you're doing well. You're making OS and Rust. Wow, that's awesome. I know you were interested in that earlier, yeah. But what are you what's it gonna be like? What are the unique things you're doing with it? If freeze K active. That should never happen. This case should never happen. Yeah, this isn't the most efficient thing since we are looping through the whole thing every time, but also fuck off, I guess. Like, I don't know. What I should have done is I should have had 3 different lists for LOD, but I didn't do that, and now I was looking for a job and then I found a job, and heaven knows I'm miserable now. Wait. Oh, that's cool. That is sick. Yeah, I mean, GNU is the way. GNU is the way. It's definitely the way. Alright, I think this is just solid. This is just, you can just send this to the bank, to be honest. Send it to a bank, you know. Now what else? There has to be something else that I'm missing here. Has to be. I don't know. I think it's all good actually. After that. Oh right, yeah. So we need to, after this, we go into chunk, into our chunk data, and then we need to actually slot it in. Actually, we should probably do it beforehand, huh?
Procurement managers, Granger is the go-to
LOD
partner that
indexed
helps
by
healthcare facilities
not
with
I job
operations.
count. It's gonna
Because there's
be
no
J for the
time managed orders and
index.
deliveries from multiple suppliers,
Um,
Granger offers everything in one place, from disinfectants to lighting, air filters, and more, all with fast delivery. that
wait,
helps
no, this
ensure
is gonna be
you
the
always have what you need
freeze
to put patient
I
care
dot
first.
index.
Call
Yeah, yeah,
local
yeah.
at Granger, click Granger.com, or
And
just
then
stop by.
this is just going to
For the
equal
ones
job
who
data.
get it done.
J. Yeah, right like that. Make it support other than GNU, because I heard GNU is spaghetti code. I mean, it kind of is, but also it's the only thing that isn't white collar bullshit. So I'm a big GNU fan, personally speaking. I think it's done. I think it's done. I think we send it to the bank. The problem is, so what else are we missing in job data? We have, oh right, the replacement index, replacement LOD. Absolutely gotta do that one first. We got free. We already do center, min, and max. And then the free flag should be set to not true. And then the LOD should be set up as well, I feel like. Okay, so we do set that one, but we don't set this one. So we can do LOD equals LOD level, and then the last field we have to do is free equals false. And now we just copy the struct. Yeah. Quick question. Have you got the new PC? What new PC? I have an old PC that I got out of the garage that I was doing the Windows XP dev on. And that is the one that I'm streaming off of now. But as far as like a new PC, no, unfortunately not. Unfortunately not. But I think me not having a good PC is probably good for content, don't you think? Like, I don't know, would you really want to watch me if I was like doing fucking, I don't know, ray tracing or some shit? I don't know. Not to say that shit, it doesn't take any skill, it does, but I mean, it's kind of like my thing to do weird shit, you know? Okay. Okay, I like it. Okay, but the replacement index. So the replacement index overwrites this. So if job data j dot replacement, oh fucker. Okay, well I made a mistake making this uint, but that's alright. That's easily fixed. It's the replacement. We gotta set those to -1. Not gonna lie, those boys have to be -1. Absolutely need to be -1. And so if it's not -1, then we need to not talk about any of this bullshit. Oh, also this freeze I can't be this. It's freeze F, obviously. So if our replacement index is -1, then doesn't equal -1, then we do that. If it is -1, then we already know which one we're using to replace, so we don't have to have any of this stuff. We just straight up do F equals the replacement index itself. No, 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 no. No, no, no. You still have to. You still have to. You just want to destroy that old one. If it isn't -1, then you want to destroy it. And that's what we're going to do. So we got to go into our chunk data for the job data j dot replacement LOD, indexed by the replacement index. Shout out the replacements, good band. Replacement index dot free equals true. We just get rid of the one that it's replacing and we slot it into a different free slot because obviously we can't replace it since it's in a different LOD array. Okay, there we go. So that was fixed. That's fixed now. I'm wondering if we can just send this, dude. I'm wondering if we can just send this with no regrets. I feel like it's possible. I am kind of worried that it is going to break my computer though. So there's also that. Okay, so let's just do it. Let me check what's in this function because I haven't checked this in a while. So we just set the LOD to the LOD. We said, yeah, get the resolution in there. All good, all good. All good, okay. No doubt, okay. Okay, well, the good thing is that I'm streaming off of this old PC, so once again, okay, so I thought that we would be seeing something. No slots for given LOD. Okay, well that's definitely not true. I'd probably just like flip the sign here. No slots for given LOD. F equals -1. If freeze k dot active and freeze k LOD equals LOD. Okay. Oh, I don't know why I did this like this. Why did I do it like this? Why would I be indexing it like that? But also, it should still work anyway. Are we queue sorting? We're queue sorting the entire thing. Queue sort the entire thing. So we never get into here. Shit. What? LOD 0? Okay. Interesting. Maybe we should try only sorting what's important. So let's just do in free count equals 0 and not. Why does my computer sleep on going to sleep, man? Oh shit. Because we don't do this, obviously. Oh, okay. So that actually, this has nothing to do with that. Although you definitely do want that. Although, hold on, every chunk has a free score. It's just that you want the free chunks to go first. So, really, you want to do this, and then like have the score be like -99 or whatever, you know? Do those first, the free ones, because the free ones don't have any data inside of them. Yeah. There we go. Okay, so we did it. It does it, so we aren't doing it in real time, which is why it's not a lot, but now we can do it in real time. Now, will my computer survive it? I have no clue. Remember the last time we did this, we had some VRAM issues. Okay, so I can automatically see that we are doing chunks multiple times. Okay, so it has something to do with the center chunk. Huh. Okay. Okay. I mean, we're kind of cooking, but it's not good. A good question is like, why do we have chunks overlapping? That's a good question. That is a good question. Our already done is based on yeah, I gotta get music. I know. Oh, dude, I want to hear this. I want to hear this though.
Get tax expertise without hidden fees.
No. Oh, nice. I got it.
Galaxy S26 Ultra for $0. No trade-in needed.
I might get copyrighted for this though. I hope I don't.
Here's President Trump endorsing Burt Jones.
Dude, can you fuck off, dude? What? Dude, what about my like SEO says that I like am a Trump fan? I just don't think that we're really like I'm in the demographic, dude. I like when people say like, oh, AI is gonna take over the world. Like, AI is not gonna take over the world because they can't even fucking figure out like my deal. They can't even figure me out. Okay, so this isn't working, I feel like. We gotta get rid of that. What if somehow my bounding boxes is wrong? Like, it could be possible, I guess. So my min is the chunk pause minus plus the min offset. Min offset is the chunk world size divided by 2. That should be correct. Should be. But things aren't lining up exactly. tough. I want to see if we ever get this. Let's clean up the printouts and then try and see how what is happening here. We could also just like get rid of this for now and see if that has something to do with it. It's kind of like an optional thing right now. I'm also realizing that our freeze array doesn't go to max chunks. It only goes to the max chunks for each. Holy shit, that's loud. Fuck, my bad. It doesn't go to the max chunks for the entire thing, which is important because we're indexing it like this, and so really we shouldn't be indexing it like that. So let's not do it that way. And now we only sort the free count, and so we should never be going out of bounds. Okay, let's test that out. Yeah, the fact that we it's like it doesn't seem like it doesn't get that I'm already done. It's the problem. Huh. Yeah, I have no clue. Yeah, somehow we are. It is not telling us that we are within the bounds of certain chunks. So that's what I'm trying to figure out. Maybe I'm iterating something wrong or something. I don't even know how to debug that in terms of like so down one, yeah, I mean, how are we getting does it say no cam chunk found? It does. I'm pretty sure that every time it does it oh, because oh no, but huh. So it's not finding this. Let's check the position. Because if it's right on a boundary, I need to know. Maybe we need like a little bit of a grace, like yeah, so it's right when you step over the boundary. It's right when you step over the boundary. I wish I could see the min and the max that gets. I mean, I could just like debug print out the min and the max for exactly this one. Maybe it is just floating imprecision. I don't know. Yeah, let's just do like an epsilon, right? Let's just do 1e minus 4. Because that's probably what it is that we need that, but I typically like to err on the side of caution when it comes to, like, you know, just throwing epsilons around for no reason, but no, it's still happening. Maybe like let's just try a bigger epsilon, I guess. No, it's still... I wonder if it's somehow that the chunk data gets set to free, but I mean, then it wouldn't be rendering is the thing. Like, if a chunk data is free, then it's not rendering. We can technically see if it's dependent on that and do this, I guess. Like, I don't... Oh, but you need the... Hold on a second. So the LOD with the freeze eye index equals the job data J. Freeze f dot index. Okay, it's much more stable now, but see that aliasing? It's because we're generating chunks on top of chunks. That's the problem. But now I'm not getting the... I rarely got it. We should really never get a no chunks, you know, where we don't find it for a given thing. Huh. It can't be possible that we do the same job twice in one go. I don't think so, based on our thing. Okay, I think we're indexing everything right now. But it's still not working. I think the problem is this node cam chunk found. Like that. Yo, what's up, Prod? Yeah, I've noticed. So this, the fact that this goes off sometimes, it should never go off. What this means is that we didn't find a chunk for the camera that's that has the camera inside of it. And in the case that happens, it's just really, really bad. Really, really, really bad. Because then we just go based on the cam position. And if we ever go based on the cam position, then we just aren't chunk aligned anymore. So we should never be doing this, I think. We should really find the chunk that's the closest to the center and be using that, I think. So let's do that instead. So let's have a float closest dist and have it, like, you know, set it at float max, and then just like push it down, right, by this dist. Instead of doing this, we just just like that. Dude, I'm goated as fuck. Thanks. Thank you. Okay. Okay, so obviously I would love to have a chunk here, to be honest, but it's not perfect yet, but it's slightly working. So this is obviously, so we do have like priority, but we're missing one here. The reason why we're missing one is just because we have no priority for LODs. Yeah. Because I wanted to be. Oh, that was a bit of lag. Okay. Okay, so we don't have anything that does this for the LODs. Right, so if the LOD level doesn't equal the LOD, then we create a new job. And then we do this here. And then set it to free. So now we, yeah. The problem is memory. Holy shit, what's that? The problem is memory, like, so we can only have one, we can only have one chunk at 60, at LOD 1, and so that's the problem. That is the problem. That is the problem. Are you experiencing neck pain, my friend? Your neck looks a little crooked. No, I'm fine. So in those cases, it's not getting rid of the old ones, probably because it doesn't. Maybe I shouldn't be doing this. I shouldn't be doing this. I don't understand. It's still drawing even though we free it. Maybe we should free it down there just in case it If we free it, then we stop fucking rendering it, right? Like we don't render free chunks. If it's free, we continue. So huh. I wonder if we're like going out of bounds, because I don't have anything that goes out of bounds that checks for us being in bounds or not. We could make it that every time we just enter into a new chunk. My shirt is loose. Yeah, I mean, yeah, that's probably what it is. I don't really like sit up that well, you know, but it's fine. Man, I don't fucking know. Kind of no way for me to figure it out either. It's kind of. The weird thing is that it's like. Okay, here's my idea. Let's just go within frustum. That's my idea. Let's just see what it's like if we just do distance. So I have a feeling that maybe that's not working. Holy shit, chill the fuck out. What? Yeah, distance isn't a good way to do it, I think. distance isn't a good way to do it. We shouldn't be doing this. To prove it, then let's just hard code it just so that I can prove my point. Let's just prove my point that there are only 2 LODs that should be valid here, so let's just hard code them and then like stop doing this. So let's just literally do if x equals 0, there, that's fine. So now everything is just going to be LOD 2 other than the center. No slots for given LOD. How? Both should end up maybe I'm hitting the maximum, I guess. I don't know. We're running out of slots. Even though we shouldn't be. Because we're 3 by 3 by 3. Maybe giving us a couple of extra slots would help, but we have max chunks of 120, but our max chunks LOD is this. Oh, yeah. This has to be, because so it's doing LOD 1 instead of LOD 2. Okay. So why? Yeah, what is the flashing about? Yeah, nothing can be fucking easy, can it? See, now it feels fine. Except there, it didn't really work. Like, why are we still drawing those? Like, how are we still drawing them? What? The fuck are you talking about? It isn't during my initialization that I fuck something up, right? Hold on a second. Hold on a second. I don't think that I clear that. I don't think that I clear that. Yeah. I don't actually clear it. I don't clear it properly because I'm supposed to do size of int times chunk ID. Yeah. Oh. Yeah, I'm supposed to shift it off by the chunk ID. Oh fuck. Oh fuck. Oh fucking shit. Oh no. Oh no. Oh no. Oh no. What the fuck was that? Oh, wait. This is supposed to be the offset. My bad. It's a offset by chunk ID. Okay, so we still... Okay, so now we're deleting chunks in the distance properly. So that's correct. However, the flashing is still occurring. And then those two just emitted on top of each other. Okay. Okay, so we still aren't. When we assign a freeze f index, it's guaranteed to be equal to the LOD. That's fine. It's only going to be a problem if we want to do two at the same LOD, which we don't. We don't see no slots for given LOD. We don't. That would mean that we wanted to do two like ones at LOD 0, and we just like kept on overwriting it. Let's see what the center pause is. I wonder if the center pause is what's flip-flopping when we see that flashing. That would make sense to me. How's it flashing? Yeah, so basically what's happening probably is that it's freeing a chunk one frame. It says, okay, get rid of this chunk, and then it wants it the next frame. So that's what's happening. I just need to figure out what value is shifting between frames to make it think that, like, there it was. So it's when it's on the edges of the view frame. So there. So the center pod is completely correct every time. Okay, so everything here is consistent. Okay, so the center pause is not switching. The bottom chunk is flashing. It's not flashing anymore. That was because it couldn't find the camera chunk, but it's not flashing anymore. Let's see the chunk ID for this one. Everything also seems to be going in a grid now, which is good. Oh, fuck. Oh, that's why. Oh, we're supposed to be... my debug for this was wrong. It's supposed to be at 222. Yeah. What the fuck did I just do? Yeah, so that's why. That is why. I was making the one of the chunks at the off center, the center. Okay, so there we go. There is still some flashing. Also, yeah, so there. I think what's happening is that it gets freed and then it gets emitted again. Wait, hold on a second. Oh. Oh, okay, so I think what's happening is that we are emitting twice over the same one in a frame. So it's on the free list, we replace it, and then yeah, I think that's what it is. I think that something replaces it, and then it also wants to emit from that thing. So let's try once again without the replacement thing. Yeah, it still is flashing. See, like here, it's fine. But here we're just missing. We're missing chunks. Yeah, I think so. I don't think that this is alright, peace out. I don't think that this is a bug that's any bug with my code. I think it's a logical bug. I don't think that I can do it this way. Oh, I already have this. I thought that I had it for a sec. Hmm. Wait, hold on a second. This is supposed to be a 1. That's supposed to be 1. Yeah, I don't know why is it? Yeah, yeah, yeah. Yeah, it is. I mean, it doesn't matter though. I think we're sometimes creating empty chunks. I think that we're sometimes just creating empty chunks. That's what I think. So I don't even know if that's like a fault of the thing or not. I want to go see, there's a bunch of empty chunks. Chunk 0 has 0, 0, 0. There's 48 triangles. So I think we're doing it. It's just not I think sometimes it just isn't doing anything. What if the size of LOD 2 is too low? What if that's the bug isn't really a bug at all? It's just can't mesh at 12 or whatever. What if we just turn LOD level 1 to there? See if that works. Yeah, I'm probably indexing something wrong, I guess. I don't know. The thing is, the chunk vertex offset is wrong. So it's that's wrong. And I did make it 120 chunks everywhere, right? I'm not being stupid. I didn't do it here, but I don't think I'm using density data anyway. I think I do it by hand. And max chunks is 120, so I did that correctly. Yeah, so I did this correctly. I definitely did. Is there anything else in chunk data that I need to set? No. It should automatically get copied with the struct. And I read out here fine, right? God, this is confusing me now. This is really confusing me. How... I wish I could just set everything to max LOD and try it out just to see if I somehow broke the fucking pipeline and, you know, figure it out that way, but I kind of can't, unfortunately, because of VRAM issues. And this is correct, yeah. This is not correct, yeah. Hold on a second. Oh, fuck. Hold on a second. Wait, is that... Oh, shit. Oh, shit. Oh, shit, oh, shit, oh, shit. Was I... But why? How? How did everything look fine though? If that's the case, then how did everything look fine? Oh, I got rid of the actual thing here that does yeah, so this is supposed to be indexed a different way. It's supposed to be indexed like this. I got rid of this earlier, and I just wasn't thinking. I just literally was not thinking. But I just kind of like, I just sat here for a while, and then I just like kind of realized, oh, I don't know why I got rid of that. Yeah, that should pretty much be that should solve it, I think. If that doesn't solve it, then I have no clue, but that doesn't solve it. So chunks are still happening on top of each other. Dude, why is my monitor asleep? I have this set up so that it does not fall asleep, and then it does fall asleep. It's so frustrating. Okay, so chunks are still, for whatever reason, happening on top of each other, which is concerning, but for the most part, it seems better. It does seem better. Because we fixed that bug. I just kind of want to like make sure that there's no further bugs with it. We do still get chunks with nothing inside of them, which could potentially be a thing, I guess. I think we're fine though. I think now it's just a bug on our side, not the GPU side. But I still don't know how we would be putting chunks on top of each other. Oh, it's because I got rid of this, that's why. That is why. What's interesting is that we don't, like, it's these chunks in the beginning that get 0, and then as soon as if you keep walking, then things become better. But still, like, we're missing chunks. But then we stop missing chunks after a while. Like here, at this point, we aren't missing chunks anymore. Or now we miss a chunk. See, here we have a bunch of zeros. So it's like chunks are getting... Are chunks getting emitted at 0, or do they just end up 0? Or is it always the same one? So 16, 16, all the way back here. 16 is 0. 16 0, 16 0, 16 0, 16 0, 16 0, 16 0. And then 16. Okay, so we do get some done. So it isn't the same ones every time. But some of them do get 0. Still. I almost wonder if it's like the density field from previous iterations is not getting cleared and therefore causing some problems. I suppose it's possible, but we wouldn't be touching the same portion of the table at all. We wouldn't be touching that part of the table at all. So it's not that. Okay, so I mean, I could just code something that if it doesn't have anything in it, then we just prioritize freeing it. But it should never have anything in it. It should never have nothing in it. Let's get rid of updating LOD level again. I know I'm like repeating myself here, but it's so fucking strange that like right here, for example, right here, why do we have chunks at 0? Chunk ID 1 pause is right where the camera is. Actually, why? Oh right, the world size is 2, so yeah, that makes sense. So our chunk ID 1 has 210 triangles only. And there are all of these empty slots. Let's print out if they are free. Oh, we don't print out if they're free. So they aren't free. So they aren't free. There's gotta be something that I'm missing that's fucking stupid here, huh? I have to be missing something really fucking stupid. Yeah, I mean, I must be missing something here that's fucking stupid. God, stop. Everything LOD1, I guess? Everything on LOD1 with, like, max chunks LOD1 to, like, 30? I like... Let's have no LOD2 chunks. Yeah, I've got no clue anymore. How's it going? It's fine. It's just there are chunks that are being made with zero vertices in them. So I don't really know what to do. Okay, so here's what I'm gonna try, I guess. Like, let's just go. Yeah, let's just go and I guess. So let's just hard code it. Let's just hard code it for a second. Just hard code the entire thing. Do it all at LOD2 and prove that that works. And not do anything already done. Let's just see if it works. Okay. Why the fuck is it not working? Why? Was there any error or what? No. There's just no cam chunk found all the way down. Don't we set it? We set it to not free here. With the chunk ID. And why doesn't it work? Job data J. To I. The center. What? What? Or we're just not getting jobs? We have 27 jobs. Oh, hold on a second. It's because I put no LODs at 2, that's why. Okay. So that works fine. So this is fine. Okay, so that proves to me that I'm not crazy. So that was the sanity check for us. So what has to be going wrong is inside of here. It's something here is going wrong. I think what's happening is that we're freeing something while we emit something. We emit something into a slot that we free later, if that makes sense. But how the fuck do I even avoid that? That's like so hard. And also I have this freeze K active thing. So that means that we always init freeze K dot active equals true. We do. Yeah, I have no clue. It could be this inside chunk thing, I guess. How good am I in C? Scale from 0 to 100? I mean, how do you expect me to, like, test my own skills? I don't know. I don't know. Two frees can't have the same. Can't have the same one. I'm okay at C. I think I'm at the point with C where I am, you know, I'm at the point with C where I guess none of my, like, errors are C related. It's all logic related. It's all, you know, me trying to figure out how the fuck to build a chunking system sort of related. You know, it's not, I never am like, oh my god, how do I write C? You know, that sort of thing. So I don't think, you know, you know, I'm kind of clocked out of this thing when I check my phone in the middle of coding. Yeah, I mean, like, this is pissing me off at this point. Let's do this. There's no way that we do the same chunk twice, right? Okay, here's a good way to test this. Okay, so this is us hardcore testing it. So int already emitted. Okay, and now we will see you do not have to write 2 for loops. Why, Kiel? Why do I not have to write 2 for loops? Okay, so it isn't that. We don't emit it twice. Why don't I have to write 2 for loops here? I'm checking this nested. Fuck. Oh wait, hold on. You're supposed to go and then I doesn't equal j. But we didn't, wait. Oh, I guess we're not doing those in that frame. Okay. You can do vector stuff in just one for loop. What are you talking about? There's no vector stuff involved. Okay. I'm not seeing any. What I'm doing is I'm checking if this is within it twice. So this is the ones that we're checking against, and then this we're checking through the entire array. This is what the code is doing. Fuck. Okay, so it's not that. We aren't emitting it twice. We aren't emitting it twice. So if we get rid of already done, then it just works, right? If we just emit everything all the time. The thing is, we push all of them onto the free. Oh, I see. So if the same... Okay, so... Hold on a second. No, if chunk data is free, then I continue. I continue if it's free. So that doesn't affect it at all. Hey Luca, what's up? I'm alright. It's just I am struggling with this for real. I really am at a loss with it. Yeah, it's fucked up, man. It's fucked up. It's a chunking system. So basically I have a list of all the ones that we can free. I queue sort them based on a score. And then later on I have the ones that we are omitting, and then I score those as well, and then I loop over and then I try to slot them in. The problem is that some chunks are just black. So yeah. The way that I want to sanity check, honestly, is I want to maybe try like putting this into a different array and then at the end just mem copying it. That would kind of sanity check it for me. Let's try that. Okay, so now what we're gonna do is instead of this, we'll just push it onto that array, and then just cd new and cd new LOD freeze f dot index equals dot free equals free equals true equals false. I'm tired. And now we get rid of this, and all I want to do is I just want to mem copy it after, because oh, actually, that's not going to do anything. shit. Yeah, that's not gonna do anything. I think the problem is probably that we're freeing something or like writing over something twice. But yeah, this actually isn't going to tell us anything. Hard coding? What do you mean? This isn't going to tell us anything. Because we've already read from the array. We're just writing into it in a certain order. Do we have no slots for given LOD? No, we don't. We don't have that. It's just that they flash 0 and for colors. I don't really think that would help. Yeah, this fucking sucks. How about this? Technically speaking, right? Every chunk should line up with another thing. So in that case, what we should do is try just like not queue sorting. Let's try not queue sorting. Try not queue sorting. Now everything flashes. How the hell is this happening if we're not going into the same index twice? That makes no fucking sense. They should both be the entire value, the entire thing. Job count, free count 59. Job count 18. Why is job count 18 and not 27? Probably because of already done, I guess. Oh, hold on a second. Hold on a second. Hold on a second. Ah, it's doing the other half and then getting rid of the other half. Oh, ha. Okay, so it's... Okay. Okay, okay. Okay, so if already done, then we can't skip it. We can't skip it if already done. Okay, so we can prove this like this. Let's just have an int skip list to index by LOD max to max chunks. Just writing it on paper. I'm not gonna do that right now. That's not it. We're gonna set this to let's just have a boolean skip list. So we can't touch these chunks in a frame for this. So skip list li equals true, and then down here if God fucking damn it, freeze k dot LOD if skip, fuck you. Sorry, it's just skip list freeze k dot LOD freeze k dot index continue. Okay, and therefore we're never going to emit into something that we skipped, and now that goes away. The flashing goes away. However, we are missing chunks, obviously. We're still missing chunks. There's no flashing, but we're missing chunks. Because some are 0 now. Why are they 0? Why are they fucking 0? If I remove it completely, it works fine, right? I just need to make sure. Yeah, then there are no chunks that, because we do them every frame now. However, this, when it's already done, we skip it. But why the fuck? We're doing them all at LOD level 1. Everything is LOD 1. And we never run out of space. We have 30. 30 should be enough. We should never be above 30. What is happening is we are seeing a chunk that has been already done. However, it has no vertices fucking in it. God. Why does it have no vertices in it? Why would it have no vertices in it? Let's think about this. So when we emit a chunk, we're guaranteed to have some vertices, but we aren't always. There are cases where chunks should have 0. However, these are not those chunks. And so somehow these chunks are getting the bounds of 0. Somehow. It has to be happening. So how the hell would that happen? How the hell would that happen? How the hell would that happen? Hold on a second. We skip here. Oh, we skip here no matter what. If already done. So there's no need for a skip list then. We should never be... Oh, but we free it. Free and write over the same thing. Yeah, but I tried this. I tried getting rid of this. I tried getting rid of all of this. And it still didn't work. I tried just emitting into... Oh, but then it's possible that you just go over... Yeah, it's possible that... Oh wait, no, it shouldn't be. It shouldn't be. It shouldn't be. You should be able to just set this to I, and it emits. Why? Why is it flashing in this case? They all happen in here. Oh, because we we skip them because they're already done. We skip them because they're already done. That's why. Okay, we aren't doing the skip list though. With the skip list, we should have a perfect 20 something. Yeah, so exactly. So now it's perfect. There is some flashing still. Okay, and now we have this problem. I'm too fucking stupid to figure this out, I think. Like, I don't know. I mean, I get what's happening, I just don't know how to fix it. It doesn't, there's really no way for me to fix it. I probably have to just think of a different method to do this. It's not a bug, it's just a logical inconsistency. Do I disable the backside from rendering? There's backface culling, if that's what you're talking about. It's built into OpenGL. Yeah. Obviously, it's not going to work when we can see through it because there are holes in the geometry because of the chunks. Yeah, it's built in. If you have normals, then yeah, it does automatically. The thing is, with the skip list, we should never be emitting over... With the skip list, we should never be emitting over the... Google my condition? What do you mean by my condition? What does that even mean? I have a feeling that this isn't working. I have a feeling like this isn't working. I wish that there was an easy way for me to check if this is working, but it's kind of impossible to check because this is a nested loop against 27 chunks. So I guess it's not impossible for me to check it manually, but fine, we can try. At this point, it has to happen. I need to know if it's within the min and max of or I mean, there's no need to check this is the problem. But I guess we can. Let's check the centers versus the... Let's check the centers versus the bounds. The problem is that we are emitting things while we are also freeing those same things. That's what I feel is happening. We are somehow that is happening, I think. I think that the reason why it's hard to track down is because for some reason we are emitting the same chunks twice, and therefore it looks like we don't have geometry. But I have to check this. Google my current problem? No, there's no. This isn't something you can Google, y'all. It's not something you can Google. Okay, let's check it. Yeah, there's a ton. Okay, so a lot of these match. I kind of wish we checked out the ones that didn't match, to be honest. Let's actually I want to see 024. Yeah, that's correct. Checking chunk at 204. It's not centered. Oh no, it is centered. It is centered. What am I talking about? 204. -2. Oh, it's 204, not. -2, 2, -4, 02, -4. -2, -4. Yeah, so I'm assuming that these match at the bottom. We just don't have the printouts for when they match. But honestly, it looks like everything probably matches at some point. So job count is 0. Job count was 0. Let's see. Is the job count really 0? Yeah, so there's still. The job count is 0, but we are missing geometry. So. Fuck. Yeah, I mean, this doesn't tell us anything. Doesn't tell us anything. The only thing I can think of is that maybe this job data thing isn't working. Like, Oh, wait, hold on a second. Oh, but I'm not even doing anything like that. I'm not even doing this. So that wouldn't even matter. I mean, we could try the replacement index thing again, but I mean, I just don't think that that's going to solve the issue that I'm having. I mean, I could just cheat it by literally just like saying, hey, if there's 0 vertices in your thing, then just like, you know, fucking recalculate it, but that's just not a good way to go about it. So, yeah, I think, to be honest, I need to take a break and get a coffee and come back to this, because this is starting to get me really pissed off. Yeah, I don't know. I mean, it's going to tell me that it's already done. Like, look, like, you know, it's going to tell me that these chunks are already done. The one at 0, 0, 0, which is the one that we're in, is already done. Or, never mind, it's 0, 0, negative 2. Oh. Oh, no, yeah, 0, 0, negative 2 is done. And so the fact that that's already done and that chunk has 210 triangles in it, which is not the correct amount of triangles, just doesn't really inspire confidence. Now, something that we could do is just like, I think what we should do now is just like follow one around. Like, if freeze f.index equals 1, then we just printf some bullshit here, starting mesh, for and then let's put in the center of it, so that we know what the actual data is. Let's not go from job data, because this is like the inconsistency that we're trying to resolve. So let's just do that. So we're gonna get the center again and again and again, and we're going to check against it. Okay, so this is going to be this. So at the index of 1, which is the camera chunk, okay, so obviously it's all the way at the top. Yeah, we should really get rid of the other printouts while we're doing this. Okay, that's what we'll do. We will get rid of this, obviously. We want to get rid of this for now. So let's just let's get rid of this in general. I don't know. All right, peace out, Luca. Good luck on your road trip. So we mesh the chunk once, and that's it. Okay. So this is what we want to check out now, is we will put this back in, and we just want to check, when we mesh it, does it have a correct amount of vertices? That's what we want to know. So we are meshing the chunk, and it has 210 vertices, which is exactly the amount it has down here. So So yeah. And it's the same chunk, right? Yeah, it's the same chunk. Or actually... Our cam didn't hit the ground, so... Or it did hit the ground. Well, maybe not. Well, anyway, it's 210 all the way. Yeah. So the problem is that it meshes it at, and says that it's 210. We passed in a uniform vec 3. Okay, so here's what we know for sure. We know that the chunking is correct now. It's just that we emit the wrong amount of vertices there. We emit the wrong amount of vertices. Hold on, here's a question. We do set size into both. Size is LOD res to LOD level. And LOD res is 52 to 24. Here's something I want to check. What if we set this one to 34 and then check it? No. Now it's just slightly more vertices. So it's got nothing to do with that, I guess. No, it's not that, I guess. If anywhere this is wrong, then we would run into some issues. I don't think we're running into any issues there though. I think we would see some distortion on the meshes if that was the case. Is this in any other... Fuck. This is in any other file. Okay, that's old. Okay. So this is completely refactored. It doesn't matter. Okay, so it can't be that. Sorry, I'm kind of like locked in here trying to figure it out. I'm just like going over every single piece of code that I wrote to make absolutely sure that I did everything correctly. Because if one number is off, then obviously that's not good. I don't think that it's anything CPU side though. Based on what I just did, I don't think that it is CPU side. All the stuff that I checked does not clue me into it being CPU side. There's no way that we are unless we clear it twice. Yeah, but I already checked that we aren't going to emit. No, but no. No, if it meshes it, okay. So let's check that then. So let's not only have the printout here, but also have the same printout. Let's have the same printout right when we mesh it, so that we can prove it, because that's the next question I have. Is it, do we do it but then we read over it, write over it? That's what I think. That's what I'm checking right now. Also, it's supposed to be ints. Or no, it is supposed to be. chunk 210. Okay, so the main thing here is that it never chunks it correctly. It never does it correctly. It never does it correctly. We can let's try the density vertex SSBO instead, and let's just offset it by, let's just read this out. Let's just do this out, just read that out, and then see. It lagged a bunch. It says 210. Yeah, it says 210. Let's prove it like this. Let's go beforehand. We do, we'll check it, and then after we'll check it as well. Oh, it's supposed to be int. Alright, so let's just check it before and after. So 0 to 10. That's exactly what we expected. So that proves that we're not crazy. We are going inside of it, and then we are getting 210 back. So what is the case? Okay. I want to see now if we ever get into here with the same chunk ID twice in one frame. We should just see it once. Okay, well, now I probably missed it, yeah. Okay, we just see it once. Why are we... did I fucking... fuck something up? Why? Oh, I did. Oops. Anyway, we only saw one done, which means that we only go through it once. Let's try LOD level of 0. Oh, but we can't, we obviously go out of bounds, so we can't have LOD level of 0. what instead we can do is that we can just like go inside of here and then go to our LODs, and then max chunk to LOD is this. So if chunk ID is but no, we can't. We can't do that. We can do it from within this function, but it's kind of annoying. You could just hard code it like this. If freeze f.index is 1, then we can hard code this to go to LOD 0. It's an index of 1. It's already 1. I waited too long and now it's going to take forever to scroll up. No. Still 210. Wait, but... Oh, I never changed LOD. That's why. Fucking stop, please. Why are we not printing that out? Oh, what am I doing? There we go. And 972. Let's see if it's correct. I doubt it is. 972 is very small. We have this. We have this small amount that gets omitted. Very small amount. Okay. So that tells us a little bit, but not that much. So it is possible to get things on these empty chunks. It's just with a very high resolution. So there is data inside of it. We just don't have a lot of it. Next step is to read out the next step is to read out the margin cubes or the density field. So this doesn't get done very much, obviously. If I had to guess, it has to be something with either the density or how it's getting indexed, I guess. Okay, I guess let's read out the density field. Like I don't really know what else to do. Yeah, let's read out the density field then. Let us read out the density field. There's really nothing else we can do. Fuck you, man. We need to take the density field out, and so this is going to be LOD res at size plus 1 times size plus 1 times size plus 1 times that's it. And then we're just going to read into it from an offset of don't I have this LOD density sizes LOD level times size of float, and we just have one offset since it's the second one is the one that we're checking, and we just want to read out exactly that much. And we're going to copy in that much from P2 into out, and we're going to unmap the buffer. And I want to see what the hell is inside of this. I want to see the first row. I want to see the first row. Oh, god fucking damn it. Segfault. Oh, not indirect buffer, obviously. The density SSBO. Oh, that is per LOD level, yeah. I have no clue if that's the correct amount, by the way. So this is LOD road plus 1 times max chunks. Okay, so that's not the correct amount. It's not supposed to be times max chunks. It's just supposed to be this. That's what you have to do. Okay. Okay, fucking Christ. We're still segfaulting? Really? Oh. Because we are supposed to obviously do what we just did. I mean, hopefully that's the segfault. Yeah. Okay, thank you. Okay, so these are our density values. It looks about even with everything else. Looks about even with everyone else. Because this out is, we're checking every single chunk, right? It's just this is the top one. It's like the first 32 or whatever. But then it's another chunks 32 and then another one, and they all look exactly the same. They all look very, very similar. So I don't know. We could do this and then just like, you know, do more than just size. We could do like size times size and then print out a fucking bunch. That did a lot. I guess. Can you fuck off, please? Yeah, I mean, this is just a lot, to be honest. We should have just exited. Okay, yeah. Fuck you, I guess. If chunk ID is 1, there. I'm just gonna do that. Please stop, man. Okay. So what's interesting is that chunk 0 has just 0 inside of it. Which is very strange. That is strange. Let's see one more underneath it, just so that we can compare. Yeah. So chunk is normal. This is not normal. This is not normal. What is the chunk center of that one? I want to see what it is. It's been a long time since I've had to debug something like this. Very long time. Like months at least. Like, I didn't have anything like this with the Linear project. Absolutely not. Does that mean it was easy? No. But it was different for sure. Alright, what's the... Chunk center is 0, 0, 0. Huh. No, I don't create a chunk. I don't pre-create a chunk, right? No, I don't. Why is it all zeros? Makes no fucking sense. What the fuck? Why is the first chunk just zeros? Are we writing into it offset? Is that what's happening? I mean, I'm kind of coping with the, can I just, like, I want to use sleep. I'm gonna use sleep. What does it include for this? I want to use sleep a bunch just to make sure that this gets bound. Everything gets bound. No, I still saw it was all zeros. Maybe it's supposed to be all zeros here. Wait. No. It's all zeros. Oh my god, I'm so fucking stupid. 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 Wait, but... Wait, what? Maybe we're reading it out wrong? Oh no, because we're writing into 3 because I told it to write into 3. I told it to write into 3. Oh man. That's me just being dumb. I'm just being fucking stupid. Because I got tilted. Oh man. Yeah. That's just me being fucking dumb. It is true though that this is all above. That's Claude's fault. I don't think so, Rob. I don't think so, man. I don't think so, Rob. Rob, I'm going fucking crazy. I'm going fucking crazy with this shit. Okay, without a doubt, we should have some vertices. Without a doubt. Without a doubt, bro. Actually, so here's what we should do. Here's what we should do. Just so that we stop fucking freaking out here. Like, here's what we do. We just set the fucking... Let's just set the ISO value to like 0.5 or some shit. And then like, if we still aren't drawing anything, then we got a big problem. See, we are drawing something in this fucking thing, bro. Yeah, bro, it's not an ISO value thing, for sure. For sure, bro. Yeah, I got no clue, man. I have no fucking clue. Oh man, I feel like I'm so stupid. I don't know. It's like so hard to figure this out today. I just don't know. The base is U size times U size times U size times truck ID times 15. Yeah. I mean, that's absolutely correct. Absolutely correct. And it matches our stride for everything. Matches our stride for everything. Yeah, I'm kind of stuck, to be honest. I feel stuck right now. I've like tried like everything. I've like printed out everything. Still like hold on a second. No, max chunks LOD is correct, yeah. There has to be something weird going on. I don't know. Something that's causing it to sometimes not do correct things. And this U-sleep didn't change anything, so this is the offset, right? Yeah. That is the offset. The chunk setter is correct. The LOD is correct. So what could the problem be? Yeah, I mean, I don't know. I think is it possible that somehow this is wrong? This? I mean, that would be crazy if that was somehow got fucked up. Also, our vertex struct, I didn't change it, right? No, I didn't change it yet. I didn't change it yet. Yeah, I mean, I have no fucking clue anymore. The chunks are getting emitted at the right place at the right time. They just have nothing inside of them. Like, and there's like, it's like I'm going crazy here. I'm fucking going crazy right now. What am I missing? I mean, like, what am I missing? Yeah, I don't know. Is chunk ID equals 1 even guaranteed? If we go back to the other printout, is it guaranteed to be the one that we're looking at? Is it guaranteed? Because then we can keep doing that, I guess. Let's just make sure that this is guaranteed to be we're looking at this. So we do all of these chunks. Chunk ID 1 1. Yeah, so that's 1 1. We do 4 4 4, and that's what we're trying to look at. So that all these chunks get done, and they have no data inside of them. So instead of doing the indirect buffer at this point, let's try and print out from what isn't the indirect buffer. Let's print out from the density vertex SSBO from here, and let's just print out from each offset, right? The int from that. From the offset, and we do the offset by, it's just int times I, and we're getting an int out. So let's see what the what if there's a difference or if it's the same exact thing. It's the same exact thing. Okay, got it. It's the same exact thing, and it happens in this order. So 19 to 23 get done, and 7 gets done. 19 to 23. What is special about 19 to 23? They all have -2 in Z. They all have -2 in Z. So that makes sense. 18 also has, or no, that is 19. So all of these in a row have -2 in the Z. However, 10 also has -2 in the Z. That's one that gets 549. And then 7 gets, no, 7 is up here, so it's also -2 in Z. However, these are also at the same level and they don't get done. And then obviously 1 is also -2. And that's the one that gets 444. So anything that these have in common other than the Z? No. None of them have 0. None of them are at 0. 0 and X. None of them have zeros. Okay. Okay, so if we are to believe that that's the truth, that 0 is the problem, then let's bias everything to not be at 0 then. So let's just like add an epsilon at the beginning. Let's just add 0.2 to it. And let's see if something changes. Now 1 has nothing. I guess I should have let it complete so that we could see what's going on. But it seems like the 4 corners. It's the 4 corners that get done. See, it's 4 corners. I'm like losing my fucking mind. Yeah, I mean, like, I don't know anymore. I don't know. I don't know. I don't know. Fuck, man. Like, it's not even the chunking system necessarily. It's that we spawn in, and it doesn't do it. It doesn't do the fucking thing. So it's got nothing to do with a specific, like, you know, anything to do with the code that we even wrote today. It's got nothing to do with it. So here's what I want to try now. I want to try to create the planet mesh that is just at that location. Which we know is 0, 0, -2 at LOD 1. We have to make it not free. I have this somewhere here, right? Yeah. See? It's actually just not, it doesn't fucking do it. It just doesn't, like... What? Like, that's crazy. That's fucking crazy, man. What are you talking about? What? Do I have a job in programming? I don't have a job in programming. If I had a job in programming, I would probably be able to figure this shit out. Just kidding. Kinda. Okay. I have a question. I have a fucking question real quick. What if we just let's push up the world size for everything. I want to see this. So let's just push up the world size for everything, and if my hunch is correct here, okay, I think my hunch was correct. Okay, I think my hunch was correct. Okay, so how do I put this lightly? There was no bug. there was no bug. So that's why it was hard to track down the bug, because there was no bug. So there you go. There was no bug. It was just that sometimes if our chunks are too small, then the density field just collapses and marching cubes can't find anything. So that's what the problem was. So it's marching cubes that basically couldn't find anything in the density field when there isn't a lot of vertices to connect them. So there you go. So there was no bug, so that's cool. Now how do I unfuck my code base now? Anyone know? That's a good question. How do I unfuck my code base now? I have no clue. There's a lot of random shit around now. Okay. So let's bring back the updating LOD level and do the oscillating thing. That's the worst, isn't it? That's the fucking worst, man. When the bug is that there isn't a bug. That's the fucking worst. The replacement index, bring the replacement index back. And let's take a look at it with everything re-implemented. Okay. So there's still that. There is still that. Meshing chunk at 0400. Emitted 0 twice. So there's two ones that are emitting on top of each other. Oh. No, it's not that. It is. Okay, so let's get rid of skip list, I guess. Do I have no slots for given LOD? No, I don't. Yeah, let's get rid of the skip list, I guess. Maybe the... Okay, so let's not do updating LOD anymore, but let's also... Let's just, let's just do that. Basically, that's just going to make it so that when we find a chunk that has a different LOD, then we aren't going to even think about replacing it. Okay, so we are emitting our center chunk twice every time. Okay. Okay, so there are still some obvious bugs with the free list, for sure. here's what we should do. If a chunk gets freed, then if the same chunk is on the job list that is already getting freed, then we shouldn't do it, right? So theoretically, if we were to do it, yeah. How do I do that though? You have to remove from the job list stuff that's already on the free list. That's basically the already done flag though. That's already what that flag does, though. See, like, how are we not freeing that to do this? Or is it the same issue? Oh no, it rendered it this time. I should probably be doing this with some less volatile noise. So that's what I'm gonna do now. I'm gonna tune down the noise. Just so that we can do it off of you know, make sure that that's not fucking with it. Density function 2. Okay, there you go. I don't think that it is fucking with it though. Okay, so there is that. And we get rid of those two, and then we don't do these two. We get those two back, and then we do that, but not this one. Okay. Well, now it's easier to see what's going on, but I still am very confused, to be honest. We aren't emitting things twice, but we didn't free that one. Oh, also, oh, we did get rid of the extra bias. No, we did. That chunk had to be getting free, the one that was in the distance. So I don't know how it could be going over it somehow. Yeah, so yeah, I think that we have to follow like a job just to make sense of it. Oh, actually, you know what? That might be what's going on. There might not be any. Do we get any no slots for given LOD? Because that would kind of make sense. Yeah, let's pay attention to the job count as we walk around. Let's pay attention to the job count. Like here. Job count 0. So my guess is that it thinks that those are already done. And what let's try standing on the empty index so that we can know if it's one of the zeros or what. I think that we have the same issue now. We are standing on index 26 and 26. It's 10,000 verts. But we aren't at 26. That is... Wait, what? Oh wait, no, we are, because now the world size is 5, so that's why. The world size is 5, so we are within this because it's 8. Oh, but this oh, that's the center. Yeah, the center. But it says that 26 has 10,000 verts, and there were no verts there, so that's confusing. That is very confusing. With 3, 4, 5, 6, 7, 8. So it looks like the center of this one is 8. And along 8 we get nothing. Until we're at -5. So 2 to -5 we get nothing. Then over here we get nothing as well. So this one's at 0, -4. Yeah. So that chunk is correct. It's 25. Has 9,000 verts. We don't see any of them. We don't see any of them. Okay. Hold on. We don't see any of them. It has verts, but we don't see them. Uh, uh-huh. There's apparently this this thing that I can query to see what our VRAM is at. I don't know how to query it. You can do gl get integer v gl enum pname GPU memory how do I use this extension? I love this guy I love these people on Stack Overflow. OpenGL doesn't give you this information, and frankly, there's only little benefit. Like, dude, what are you programming? Like, what type of dog shit are you programming? Shut the fuck up. What are you talking about? You don't need to know. Yes, I need to know how much VRAM is being taken up by my fucking simulation. Like, dude, I mean, Jesus Christ, man. How do I enable this extension? The amount of people that I see on Stack Overflow where their whole thing is like, okay, but like, how do I enable this extension? OpenGL info is missing. Oh yeah, classic. This guy in the NVIDIA forum saying, "Hey, this doesn't work." So I guess it just doesn't work. Okay. Nice. It's this? Okay, let's see. I'm going to assume that we don't have the extension. Because h null, yes, we don't have the extension. For God knows what reason, I have to put this thing in a render doc to figure out how much VRAM I have. Like, what the fuck? No wonder nobody uses OpenGL. Are you fucking kidding me? Like, that is ridiculous. That is so fucking stupid. I'm starting to think that we're just out of VRAM, and that's the problem. I think that that's the problem. That's the reason all of these go to 0. It's just that we're out of RAM. Now, why don't they go in order? I have no clue. I have absolutely no clue. We could try... How do I even prove it, though? How do I even prove it? We're going to go 0, we'll go 10. Just like very, very small amount, and then see if they all fill up. They aren't all filling up. Every time it's 1, 2, 3, 4, 5, it's exactly half. It's exactly half. Why is it exactly half? Wait, is that what it was all the time? Was exactly half? That had zeros? It's exactly half. 4, 5, 6, 7, 8, 9. No, it's less than half. But then again, some are definitely supposed to be 0, I think. Huh. Okay, so we have vertices, but we can't actually draw them for some reason. So that's the problem. So let's focus on the first problem, which is that. let's check if it's free. The one that we're on top, let's check if that chunk is free. It's not free. Unless it's for some reason displaying offset from the camera, which I doubt it, because then the collision would be off. So I doubt it. I doubt it on that one. Huh. So we have 9,000 triangles, we just aren't drawing them. And that's kind of why I think that we're out of memory. That's why I think we're out of memory. Let's try that then. Let's have the same amount, but then like make the resolution like incredibly low res. No, even at this resolution, it's still not correct. Lowest resolution possible, really. Yeah. And we're at chunk 26 again, 150. So it actually has nothing to do with that either, to memory. So like what? So we're omitting the vertices. Is it the first offset that's the problem? I don't fucking know. This is like bizarre now. Because we are omitting all of the triangles. They just aren't getting drawn. I don't think it's normals. I saw emitted twice somewhere. At the beginning, I saw emitted twice. But we're on 8:16:25. Yeah, so it isn't anything to do with that. I doubt it has anything to do with position either. Here's a question. Alright, I have a question here. I think that we are somehow no, there's no error. There's no error. Huh. There's no error and there's no... Okay, and what are we reading out from? We are reading from... Right, so we were reading from this. So let's see if there's anything different between this and this. From the indirect buffer versus where it reads from. Can you press I instead of U, please, you fucking idiots? Thank you. Okay, so let's see if there's any difference between that count and this count. No. Let's read offset of in indirect draw arrays indirect command. Let's see first. They should all be even values. The center doesn't correspond to the vertices, does it? The center doesn't correspond to the vertices. That's what it is. That's what it has to be. Hold on. So, get rid of this. Read out... read out four vertices God, I'm gonna be so happy when I don't have to do this shit anymore. This is like one of like the worst programming days I think I've had in a long time. This, whatever this bug is I mean, it's not even a bug, it's just there's something here. Okay, so vertex times I, no, you just want to read the first four vertices. For each one. Okay. But like but why are they all zero? Like, why are they all zero? I mean, that is the offset of it. Oh, because we didn't. Oh. You were supposed to do size of vertex times I times LOD res I times there. Come the fuck on, man. You can't be serious that I can't read this out. Ah, god damn it. God, that's the worst thing, man. I hate OpenGL. Honestly, next project I'm not doing it in OpenGL. I'm not doing it. I'm not fucking doing this shit again. I'm just not doing it, man. I can't anymore. Like, it's too shitty. It's just so bad. Vulkan next time, yeah. Or, you know, yeah, it has to be Vulkan, but like, I don't like Vulkan because I like old hardware, and my hardware is old and it doesn't do all the fancy Vulkan bullshit well, but like, this is ridiculous. The fact that you can't read this shit off of the GPU is just unbelievable. Like, actually. This might not even work, so. So let's just try this instead. It just doesn't like when you read back big portions of data. Hey JTag, nice to see you. Okay. We are getting some error 281s. Why? Why are we getting error 281s? Like, okay, can we just get to the fucking chunk? Okay, thank you. Okay, so we're on 26 and we're printing out 26. Stack smashing detected, terminated. Okay, buddy. So only downside of Vulkan involves a lot of newer features for dynamic and bindless are still early doors. Yeah, I mean, that's the thing. Like, my hardware doesn't even do that stuff well, so I wouldn't even be using the flashy new shit or whatever. But also, I don't know. In my opinion, just like, I don't like Vulkan, but it's also like, at this point, it's just so much easier to use than fucking OpenGL. Like doing anything serious in OpenGL is impossible, I think. Like, the more, I mean, I knew that back in the game engine, but like, that's just fucking stupid, man. Yeah, I mean, if this doesn't work, then, oh fuck, this is supposed to be L. It's supposed to be L. Just why that wasn't working. Why I was smashing the stack. This is times I, yeah. And this is supposed to be vertex times 4. I put the wrong number back. So if it wasn't for those extensions, I don't think I would be using it, because the older APIs, yeah. Vulkan has a lot of work up front. Yeah, people say that it's hard just because you have to write some boilerplate in the beginning. Like, Vulkan is brain dead is way easier than OpenGL, depending on what you need it to do. Like, OpenGL is, sure, you can draw a triangle really easy, but good fucking luck doing anything serious. You know, like, that's the problem. Like, it just is a pain in the ass. Yeah, I mean, this isn't telling me anything. This is not telling me anything. Yeah, it's just, I wanted to see the first few vertices out of this so that I could see, but we're not even getting, wait, hold on a second. No, yeah, we're not even getting valid data out of it. Maybe they just, maybe the GPU is just packing this weird, and so we're just getting garbage out. But we should be able to get, we only want to do this if I is 26, because that's the one that we're checking right now. I'm just trying to see where the vertices are in world space for this. I wrote a simple RHI abstraction over Vulkan to reduce setup. Yeah. In RenderDoc, yeah, I mean, I could open up RenderDoc for this, but yeah, I don't have it on this computer anymore since I switched over, and I don't really want to do it right now, to be honest. Yeah, let's just do the first 24 verts, I guess. I don't know. Let's also do this. Just to see which one is good and which one isn't. Iteration 4 invokes undefined behavior. What? It's in this loop. Oh. Yeah, that is true. That is true. That would be undefined behavior. You are so right about that. Yeah, I'm just seeing a bunch of zeros, so yeah. Unless that's the thing, is that it's just full of zeros, and we have... Oh, now our counts are coming back as 0. What? Why are my counts 0? What? Oh, this is first. Wait, but that still should not be first is 0. God fucking damn it. Let's just find the... Oh, because I'm copying into count, not count 2. That's why. Okay. But that just kind of proved my point, is that all of the vertices inside of 26 are 0. In fact, I could read out more if I want to. But yeah, I don't think that... Let's try 126 because I like the number. And let's see, I mean, this is kind of just proving my point. It has vertices, there are vertices in there. It's just that all of them are 0. Yeah, it's just 0. Yeah, well, that's fucked. I mean, like, what am I supposed to do about that? Like, what am I supposed to do about that? All my vertices in that fucking buffer are 0, man. Wait, are you serious though? Like, you can't be serious. Let's do the normals, dude. Because like that's insane. That's insane. We can't have 10,000 vertices and they're all 0. That's not normal. That's not normal, man. That is not okay. That is not okay. Okay. The normals are 0 too. Like what? Unless I can't read back like this. Unless this is not allowed. Like let's try it for 0 and let's see if we can get anything. Like no. There, we get a bunch of shit for if it's at 0. So, if it's at 3, I bet that we get stuff. I don't think that it's a distance thing. I don't think that. Wait, no, we get nothing. Okay, are we calculating this correctly? LOD res. We are not calculating that correctly. Yeah, now I'm fucking tilted because whatever. Okay. We're not calculating that correctly, that offset. No wonder we weren't fucking getting anything. I mean, this is still, I don't think we're gonna get anything. Yeah, we still don't get anything. Even with the correct fucking thing. It's definitely times I, which is the chunk. Does, yeah. Yeah, that's correct now. That is correct now. Four you get. 4 is correct. It's weird how every third goes to like 0-ish. That is kind of weird. I kind of wonder if there's like padding issues. There's like padding issues because this like the padding on the GPU might be something, might be different. It might not be size of vertex. It might be size of vec4 times 3. No, you motherfucker. Oh my god. Why is that button combination exit out of Helix? Like every time I hit that, it's like I'm left scratching my head at who fucking designed that. Okay, let's try and see if this gives us a different result now. No. Oh, we are doing the normals as well, so that is something. So every other one is a normal thing. That doesn't really explain anything though, because yeah, the padding might be different on the GPU. Yeah. Padding might be different, I guess. Can you stop? Dude. Yeah, today is not my day. I don't know. Maybe I should do render doc, I guess, to see. But yeah. I mean, it just doesn't seem like the stride is right, man. Like, that doesn't seem correct. That just does not seem correct. Yeah, render docket? Yeah, I mean... I know, I just don't want to fucking go and get render doc right now. Like, genuinely, why, though? You know, like seriously. Like, fucking why can we not query the goddamn thing? Do you feel me on that? Like, why can't we just query the goddamn thing from in here? That's my question. I'll render docket after the stream. Yeah, it's just, yeah, I'm gonna leave anyways here soon, but what do you want to read back, the uniform buffer or SSBO? It's an SSBO. It's a very big SSBO of vertices that it's coming back that we have 9,000 vertices to draw, and we're not drawing any of them, or we are drawing them in a different place than is expected. So I need to see what vertices are in that fucking buffer. However, you know what we could do? We could actually just like change the resolution to something incredibly small and make it so that we can actually query it. Like, that's what I'm gonna do. Like, just make everything 4 so that we can just query it super easily. Because now there should be no problem with us just mapping the buffer out and reading 4 vertices out. Now, should I have to do it this way? Absolutely not. However, we can't fucking have nice things apparently, so we'll just cheat it this way and see. Okay, so zeros. At 26 we have zeros. We have 150 vertices, so I'm just gonna read out 150 straight up, just to prove that all of them are zeros. All zeros. Now, I have no clue if that's correct. Oh no, it's not. It's not correct. Because we didn't do times 15. That's why we were wrong there. So I had a feeling that it wasn't correct. Still nothing in it. There is nothing in it. Now let's query 29. Nothing in it. Let's query 180. Or not 180, fucking 13. All zeros. Huh. a query 4 just to make sure that our stride is fine or whatever, or like, I don't know. It's also all zeros, so I mean, like, that can't be right, I feel like. That can't be right. That just can't be right. Yeah, see, like, what is this? What is this padding? What is that padding, bro? What is that padding, man? It has to be, it's either vec4 times 3 or it's vec4 times 4. It's one of those two that it's padding it to. Has to be. Okay, so it isn't this probably. So vec4 times 4. I guess. So this. I don't know. I don't fucking know. I mean, maybe that is correct. Like, at the end of the day, I don't even know if it matters because I feel like we would at least be able to see something there. I don't think it's padded on the GPU. I don't think that it's padded. I don't think that they do any padding there. I don't know. That's weird. That's weird. I guess I'd have to map it the same way on the way back out actually. So I'd have to map it to vec4 as well. Now, is that gonna work? I have no fucking clue. There are zeros every third one, which makes me feel that I didn't do this fucking correctly. There's zeros every third one. Okay. I mean, okay. If I just read out vec3s, then it has to make sense. This, that, that. Okay, so here's what we're learning. I think that they optimized out the colors. I think that the colors are optimized out. Or something. Because it's supposed to be a vec3 for position. And then the normal. And then the color. And then the position. And then the normal. And then the color. So 4. It is 4. It's vec4s. It's 3 vec4s. It's 3 vec4s. Yes. Did that take me a while to figure out? Yeah. Yeah, it fucking did. It really did. Anyway, so that's the padding. So it is 3 vec4s. The zeros are the color, so that is correct. So it is 3 vec4s. And that means that we should check 26 now with all of that in mind and see what is actually in that fucking buffer. It's all zeros. It's all zeros. It's all zeros. And there's no error when we do the buffer. So the only thing we can think of is that there's something strange. Okay, so if try to debug the generation of 26, what do you mean the generation? Oh, the actual generation? It's hard. So the fact that so marching cubes, by the way. So it's marching cubes. This is guaranteed correct. Like the generation is guaranteed correct because of marching cubes. There's actually like a 0% chance. Even if somehow all of the vertices were 0, then the normals would at least exist. So if you want to like debug it, right? Let's the easy way to test this would just be to set the normals to like 1 unnormalized, right? All the same normals, and then check it. Here's what I'm thinking. I'm thinking that the GPU is padding these things, and now our stride is off into the array. I think our stride, this base stride, is wrong because of padding or something, like the GPU padding. I think that there's some problem going on there. I think we do this. I think we actually match their padding, and we do a float pad 0, right? And we do the padding. I think that's what I'm gonna do. I have a strong feeling that they padded out, and on our side it's not. And usually that's fine, I think, but in this case it's not. So I'm just gonna match their padding and then see if that fixes anything. It shouldn't be that hard to do. I have like a few shaders, right, that I have to touch. It's this one, it's density, and I'm not sure what else. It's indirect as well. That has this, and that's it. That should be it. Now let's see if we can compile. CPU side padding can sometimes, it works now. It just works now. It just works, by the way. It just works now. So that pisses me the fuck off, man. That pisses me the fuck off. I'm fucking pissed. I'm so mad. I'm so fucking pissed off, man. Are you fucking joking? Are you fucking serious? Nah, you can't be fucking serious, bro. No way. No way. Fucking. With padding, it's while the whole thing was working for 2 days and I didn't even know. Yeah, exactly. This worked fine, by the way. It worked fine until we did the chunk generation stuff. So the padding it didn't matter for like anything else we did before this. I think, so here's my like little thing. The buffer is huge. Like we're talking about like hundreds of megabytes, the buffer that the vertices are in. I think with large unsized buffers like that, the GPU just does some weird fucking optimization bullshit. I think that's what the problem is. It does some weird bullshit. It's very strange that isn't disappearing. So we have some other bugs, but the majority of it works now. Obviously some weird things that we have to solve still, but yeah, that fucking pisses me off, man, because we were like chasing this bug all day. I was like at my fucking wit's end about it, and it turns out that before doing your chunk stuff, when padding wasn't an issue, were you ever reading it back? Did I only start reading it back recently? I definitely read it back, but like not. I don't think that the buffer was ever like. It was all sized, you know. Like the chunking stuff, we literally now it's like for max chunks or whatever. Like when I was reading it back, it was always like the first chunk, right? So, but yeah. Anyway, the thing is like we weren't even, the thing that pisses me off, right, is that we weren't actually reading it back or touching it. Like we don't touch it. It's all on the GPU. It is all on the GPU. As in like the vertices are all on the GPU. It gets indirect drawn from the GPU. Here, we never upload to it or touch it, right? So here, this happens completely on the GPU. The calculation for the offset happens completely on the GPU using indices. So I don't get it. I don't even get it, right? Like, we don't take the vertex data off the GPU. We don't index into it, upload it to the GPU with indexed-based math at all. The reading back that we were doing was only for debugging. So, yeah, I mean, there's no reason for, like, this index-based thing that we do here is completely on the GPU. And it has nothing to do with a presumption about the size at all. I genuinely think that with large buffers, when you tell OpenGL, hey, I want that much, like this much, like with this large amount of an unsized buffer, I think that they assume that it's already padded or like something like that. And they don't, because technically this is like, you know, this is also, it's not times size of vertex, it's times size of vertex plus 3 floats, right? But the GPU is supposed to, you know, do that itself. But yeah, I don't know. Yeah, I don't know. Probably has to match STD 410. Yeah, I mean, maybe. I mean, it usually, so this is how like most things are under the hood on the GPU. It always like does it itself, right? So if you have this, then it's going to automatically pad it, right, to 64 bytes, things like this, right? So that completely makes sense. However, I don't touch any of that. You know what I mean? Like, I don't touch any of that. So, I've never had a bug like that where if I'm not touching it, then it should just technically do that itself. Like, that's its job, right? Like, when it gets past a buffer that's unsized, right, and it has this much, it should read this much, right, and then it finds this, and then it just does this internally. Like, that's how it works, right? So, I mean, this is the only time I've allocated like a 500 megabyte VRAM buffer, but I don't know. It still is kind of like, what the fuck, right? But yeah, whatever. At least I figured it out, and I guess next time I'll be more careful. Like, I usually pad everything myself to Vec4s, but I thought, like, I know the rules, I know how it works, like, because I don't want to pad my CPU side buffer along with it, but it is what it is. Anyway, now that that's fucking finished, yeah, that was crazy. Yeah. I'm gonna get out of here soon. It was a bummer that today just got kind of hijacked by that, because yesterday I had so much fucking momentum. I did so much, like, got so much progress done yesterday, and now today we just really didn't get anything done. So because I was kind of racking my brain about this, because no matter what I printed out, it was all supposed to be fine. So there are the issues with it, with the flickering, which I believe is that the basically things on the edge, right, that we load in, sometimes it decides that they aren't important, like within a frame, or during a frame, right? So one frame, it's like, okay, we want to put this one, we want to calculate this chunk, and then see, and then in the frame after, it's like, okay, we're deleting it, it's not important, right? And if we look over here, so that one's interesting. Well, that one's, I think it's because that one is LOD 0. I think that's why that one's that one stays. I think that's the one that's LOD 0, and so it never gets freed. It's hard to tell, actually. It looks like LOD 1. So those are the two bugs, is that, like, there is that one that's like gets stuck, and then there's the flickering things. I don't know how to get rid of the flickering things, because it's like that's within the logic of the thing itself. With the free list and stuff, I guess I could like do some like weird thing where I'm like, hey, maybe if we recently calculated this, then we don't get rid of it, sort of thing. Maybe like have an aging system. But if a chunk is reevaluated as not needed, an LRU, okay. Yeah, I mean, to be honest, what I probably... Okay, so here's what we should try. We should try the within frustum thing first, because we didn't have that. I disabled that. So we should try that and see if that fixes it. Basically, we're weighing the importance of chunks based on if they're in the view frustum, and that might just get... it doesn't. It should get rid of it. 100%. Let's check with that within frustum is working by just literally making the entire thing within frustum. because that it might not just like my math for this may just like have been wrong. I never tested it, but technically if it's within frustum it should just be evaluated as very high. Huh. Yeah, I don't think that it's correct. Yeah, that would not be flashing. It's like when you look at certain directions, it goes away. Yeah, I probably need to like, I think my math on it was correct, but this might not be correct, and the min and the max might not be correct. I took this code from the PS1 BSP stuff. But yeah, I may have to like look it up again and see. I think I build the planes correctly. I don't think that you can fuck that up very easily. Unless I don't. No, I think that this is all correct. Add sub, add sub, add sub. Yeah, I'm pretty sure that's it. Yeah. Maybe it's view times proj? No, it's proj with view. I don't know what I'm thinking. I think the min and the maxes are probably correct. I think it's probably how I'm checking for the min and the max here. That's probably the problem. I could do what you're saying with the LRU. I just like, I don't know. Yeah, I feel like the within frustum thing has to be the thing that works. How about this? How about this? If it's not within frustum, then we don't do it. If not within frustum, just let's just do this, right? And then therefore we're just going to skip it if it's not. Then let's see. This is an optimization. Yeah, I mean it's not. Yeah, I feel like it feels like the bounding box is off. Do you see what I'm saying? So the bounding box is off, or like the view planes are fucked. Like if I look down, it resolves itself. Like if I look directly down, it kind of resolves itself. Yeah. That's weird. Oh, I fucked up. I clicked, which does something. Oh, the view plane somehow rotated or something? I don't think so. Do I think it's possible that we're like column major or something? I don't really think so, but we could try it. right? That would be the other way around. So let's try it. Why not? Let's try it. I am going to dip out here soon, though. I am like really dead after today. It is kind of a bummer that I don't know. I feel like today was such a waste of fucking time because it wasn't any like bug with, you know, any code of mine. It was just a problem with, I don't know, some dumb bullshit. Oh. Okay. Well, yeah, I'm glad that I checked that. I'm glad that you said that and I checked that because, yeah, it was like, it was the other way around. It's because OpenGL is column major, I think, and my code was row major, and I didn't really think because, funny enough, that old PS1 project was row major, so that's why that was the problem, I guess. So that was good. Thank you for. Sometimes I just don't do the thing that makes sense, even though it makes sense to do it. So usually need like a little bit of a boost in the direction. So anyway, this is cool. So now you may be saying like, yeah, but this is like, this is, not a lot of geometry, but we can definitely boost I want to boost the range up, right? And just like have really low levels out there. Like just like boost the radius, but just have it like really be like low LODs. Like have like 70 of these and then just like, have them like at 8 or something. Yeah. We also, so once we have something done at this low LOD, then we don't redo it at a higher LOD. So I don't have that implemented yet. I was supposed to implement that, but that's a simple thing actually. That's a very simple thing. But yeah. Anyway, pretty rad shit. Implementing that is not hard, but I do have to dip. But yeah, implementing that would probably take like 20 minutes. I just need to have it so that that basically we set it to free when we replace it. Only doing within Frustum actually seems to be working perfectly. So we just do if we do updating LOD level, and then we say that we're updating the LOD. And so when we do it, then we just change it to the other size, and then free it the next frame. But yeah, the problem is like you need to put. Yeah, the problem is this is a little bit complicated because you have these replacement LOD level and LOD index, and you need to put those at the top of the free stack so that they definitely get replaced at the correct time. You built a Minecraft clone last year? That's awesome. Yeah, that's a lot of fun. That's probably like a lot of the, similar things that I'm working on right now, I guess, yeah. It is a little, bit painful. So yeah, so the problem with this is that we need to put it at the top of the free stack. And Yeah, we have to make sure that it gets... Actually, you know what? You could probably just free it. Yeah, you could just free it. It doesn't need to be replaced immediately. You can literally just free it, and then it won't render it. I'm still going. Yeah, I'm about to dip out. Yeah. Oh. Well, that's not good. Well, that's not good at all. So I guess freeing it still wants to exist is the problem. When you free it, it wants to exist still. Huh. So I guess that's not how that works. I thought like if we have a replacement index here and then we've already replaced this chunk, then we can just, free it or whatever, and then. But I guess. Actually, you know what? Like if we are for sure gonna replace it, then we could just do this here. Like. I mean, it would still have to be within Frustum, but you kind of want to do it like before any other jobs get done. I don't know. Hard to say. Hard to say, indeed. Yeah, because you set this one to free. A little bit of Perlin noise and one shitty algo, and I had a memory leak, yeah. Let's try getting rid of the within Frustum, I guess, just to test if it fucking fixes it. Nah, yeah. It's two LODs are fighting over the same chunks is the problem. So these emitted twice are the problems. Because it's emitting it at a different LOD. And then... Yeah. Oh well. I'm gonna figure out a way to do it. I think I just have to like... I have to like make a separate queue for... maybe for different LODs. I just make a different queue. Because like I need to like... I don't know. I need to basically make sure that we only... do things once. I also have to like make it so that we have ceilings. We don't have like ceiling collision very well. Like walls are fine, but also when you have a low LODs like this, the geometry is kind of fucked up because it's not just the geometry, but also the collision is low detail because the collision is based off of the density field. But yeah, it's pretty sick. I think we can have like even more levels in the distance, and like that's gonna be pretty cool. It did take forever to do this today, though. It was a pain. I wrote the code correctly. It was just OpenGL, which is why we're gonna do Vulkan next time. All right, peace out, guys. See you guys soon.